is this not on? Why does it say offline? There we go. All right. Alrighty. Whoops. Yeah. So, wait a little bit for people to show. Eat my lunch. I really need to remember to eat my lunch before I start, which means I have to allocate enough time to eat my lunch when I announce when it's going to be, which I never remember to do. Unfortunately, I only decided to eat lunch in between the time when I announced the start and when it started. Because I realized if I didn't eat now, I'd never eat. All right. So yesterday I tried to add some new stuff that controls the rounding of things on belts, a splitter and a balancer. I got the balancer working fine. The splitter was a little problematic. I realized it needed to be a new belt type because we topologically sort the belts. We don't topologically sort everything else. We just topologically sort the belts. Because that's important to keeping the throughput consistent. Machines, it's possible there's going to be a one-tick glitch in machines. I hope not, which would lead to them not hitting their max throughput. I think there won't be because there's sort of buffers built into the system that will hide that. But the conveyor belts, you can just see the stuff moving around, and so if there's glitches on that, it's a problem. So we topologically sort the conveyor belts. But then the problem is if you have any system that interacts with the conveyor belts in a way that needs to be glitch-free, it needs to be in the topological sort. So I started making the splitter belt, and I realized I was cutting and pasting a lot of code. So the code is really ugly at this point, the logistics belt handling code. That's because it's trying to be super compact in its memory usage and super small, super fast. So that you can make big factories. And that's causing a problem for the code quality because when I initially did the conveyor belts, I thought they were the only thing that was going to need to be conveyor belt-like. Didn't realize I was going to need these other things that have the conveyor belt behaviors and need to get into the topological sort. So there's a lot of code replication, a lot of bad design choices because I didn't know how everything was going to work in the end. So what I'm going to do today is refactor and redesign some of the systems and hopefully get the code, a much, much clearer state where it'll be much easier to add the splitter. So the first thing we're going to do is back out the splitter. Well, I'm just going to disable it. The code will still be there. The data type will still be there. So as long as I'm looking at the code quality, I want to think about another thing that's going on here, which is that I have these structures that I'm carefully bit packing to keep them small, which, as I mentioned, I wanted to keep them small. And there are a couple of reasons to keep them small. One is that makes it faster because they fit in cache. But another reason is so we can make a big factory and keep it in memory. We can't process, like Minecraft swaps out the stuff that's not around any players. And so, I don't know, I think there are tricks to keep stuff loaded, but then that slows down the server because it's now ticking everything that's being kept loaded. In the modded Minecraft, there are tricks. And people occasionally complain that the server's lagging because it's processing too much stuff. So that's more about the performance than about the size, but the size is worth thinking about too. So I have this whole system where I'm only keeping of the logistics network in a distance around the player, and it's not simulating stuff outside that. Now, I don't actually have any like swap to disk of the logistics network. None of this is really handled correctly, but that's the code is in there to handle this. The processing code is all going through an interface that allows that to happen under the hood. And the concept I had originally was that it's okay because everything is self-synchronizing. It's okay if you go away from the factory and like only half of it's loaded. The half that's loaded will keep processing. It may run out of stuff to do because it isn't getting inputs from the other half, or the stuff it's sending out backs up to the other half. So it could fail to make forward progress pretty quickly. But it doesn't get into a broken state because as soon as you move back and get everything loaded back up, as long as it's self-synchronizing, it'll self-synchronize itself back to the full throughput state. Now, as far as I know, the way Factorio works is it just always has all of the factory loaded. And I was thinking about that, and if I do my job right about keeping everything small, then you could imagine, maybe, well, fast forwarding is hard. When you if you make a deep simulation like this, you don't have a good abstract way of running the simulation. And, the redstone in Minecraft, I'm answering a question in chat, or a comment in chat. The redstone stuff does let you make arbitrary circuits. So, and then as soon as you mod things and you're adding other stuff, there's no way to know, the core engine can't know how the modded stuff needs to run at a different LOD. LODing is a great technique if you can make it work. But like, for example, I've always wanted to make a big city sim, and the idea would be that like you'd simulate cars on roads with some detail, and then stuff that's further away you'd replace with a traffic sim. But you have this problem of like the two aren't necessarily consistent. What happens if the traffic sim says this thing works perfectly, but if you go in there and run the higher LOD sim, it turns out, oh, all those cars can't fit through at that rate, and you get this inconsistency. Like, you can obviously try to tweak that, but the whole point is to make like this giant map. How do you make those two things always be consistent from the player's point of view? So the LOD stuff for simulation is really hard. I do not recommend trying to do it. So what probably makes more sense is, or what would be interesting instead is, instead of having this like dynamically loaded thing, is to go ahead and support very large factories. Very large doesn't necessarily mean low performance, because the way we define large is kind of hacky, because we're doing this sparse storage where we divide the world into these regular sized grids, and the grid is either present or not, and that is a large determinant in the storage. And so if you make a belt that just goes for 10 miles, it's going to have lots of little 16 by 16 chunks, each of which just has one belt run that it can simulate very fast. And it can actually simulate that at a reasonable speed because there's no complexity there. It's just very simple, but it's still actually taking up a lot of memory because it's so because the way the sparseness work isn't handling that efficiently. We don't allow belt runs that are 1,000 items long, which would be even more efficient, or 1,000 blocks long. But anyway, so I was just thinking that as long as I do my job and keep things small, you could easily say, well, your factory can go up to, whatever your memory limit is, but let's just speculatively say 256 megabytes. I assume a 256 megabyte factory is actually incredibly big. So one way of tackling this is to just do that. You just say, well, we'll just keep everything loaded in memory. We will process everything, and we'll live with that. Now, another thing that you can do, and I'm sure Factorio does some of this, is you try to divide the world up into independent chunks, where this is a thing that you do in physics simulation, where two objects aren't interacting with each other with their physics. Like you have four objects all pushing against each other. You kind of need to solve those as a mutually constrained system. But the four objects pushing against each other here and four objects pushing against each other here, and they're both on the ground, but the ground's immobile. They don't communicate with each other, and you can solve them independently. So you could do a thing like that where remote things get turned off, but in a consistent way. Instead of half your factory running and half your factory not running, it's, hey, that distant factory just isn't running. But the thing is, the way I was originally thinking of doing this is to just put everything into the logistics sim. So if you had trains, you could make like this really remote factory and a really nearby factory, and the trains are circling the stuff through it, and so it's still all one big factory. And so if you try to find a place to divide that, there is no place because it's all one continuous factory. Now you could try to do sort of arbitrary ways of splitting things, but what makes more sense is to have it be sort of data driven. And so you could do things like, well, the trains aren't part of the logistics simulation. The trains are their own simulation, and the logistics sim communicates with it. And so what you could imagine is a system where the logistics system is responsible for loading things onto trains and taking things off trains, but the train system is responsible for moving the trains. And so you could have a system where the trains always run, and the factories near you run, and distant factories don't run. And at least you'd kind of get this consistent state where the trains would still circulate between the factories, but they wouldn't be able to pick anything up at the remote factories because those logistics systems aren't running. That might at least be a little bit more consistent. So I'm not committing to any of these things. Clearly, the best case is just always run the whole thing. And maybe the system is fast enough that we could have a pretty large factory and just always run it. But it might be nice to go down one of those paths that allows us to decouple them a little bit more intelligently, like with the train thing that I was talking about. So somebody just asked me a question about what I just, asking how I would do, and I think it was exactly what I just answered. So if you have, if my answer was not clear, let me know. So the point of all that is to think about the sparseness, to think about whether this current design for the sparseness is a good idea, to think about how we're doing a lookup. We rely on the sparseness to locate things. We look for the chunk that lives in that area, and then we look inside that chunk. And I think it's all still reasonable. Like if you were still keeping the whole factory in memory, I think the way I'm doing it with the sparse chunks is still the right way to do, or a reasonable way to do things. So none of this actually changes what I'm going to do here, but I wanted to think through it. And it will impact like the decision to make the train. Like maybe I do want to, like I was saying, I can make the trains a separate system that the logistics system interacts with, even if I end up not using that, even if I don't end up decoupling remote factories, and I just do still run everything, it won't hurt to have made the trains be a separate system. The main problem with making things a separate system is you lose that thing I was talking about with the topological sort of the conveyor belts. You lose the efficient, full throughput interactions. But the thing with a train unloading and loading is already like kind of fuzzy. So losing one tick because the train arrives and then it unloads for 100 ticks and it only gets 99 ticks of unloading because the ticks didn't happen at the right time or something like that isn't so bad. especially if it's consistent. If you just run all the factories and then run all the trains, run all the factories, run all the trains, one tick is run all the factories and then run all the trains. It'll always be consistent, and so it can just be part of the specification effectively. So that's a thing to think about going forward. But I do think the core design is okay. I actually think I may want to make all of the machines the same size as the belt runs, make everything 16 bytes, because that will ease the memory management when I switch everything. Currently, everything is using FTB arrays that dynamically size, and that causes a lot of fragmentation. And it might not be the end of the world in 64-bit, but I'm not sure. And it might make a lot more sense to have like every chunk allocates in like every logistics chunk allocates like 1K in blocks of 1K and sub allocates from inside them. And if all of the things are the same size, if you have the belt runs that are variable length and then all of the machines are fixed size, that might be cleaner. So, right, because they're currently 12, 12, 8, and 16. But that would increase the size, so it's a trade-off. So I'm not going to touch that part for now, but there's nothing to think about. So what I do want to tackle is this problem that this code is all just a giant mess. There's a lot of redundancy. As I said at the beginning, there's a lot of redundancy. There's a lot of things, everything's being handled in place. Everything's got the code inlined instead of in functions. And some of that is kind of necessary, and some of it is premature optimization, and some of it is laziness. And some of it is because I didn't know how things were going to work when I started. But now that we have a better handle on it, it's probably worth fixing. And so the refactoring I hope I tagged that correctly when I said start. Yep, I did. And so the refactoring that I want to do, I think, consists of the following steps. First of all, I'm going to want to combine all the code, but I can't do that yet because the current problem is that actually this doesn't go in here, this goes into do. So refactor belt logistics. So what do we need to do? Well, first of all, straight belt is interleaved items. Other belts are concatenated lists. That is, the straight belt has item L1, well, it's R1 actually, R1, L1, R2, L2, R3, L3 for however many items there are. The curved belt goes R1, R2, L1, L2, L3, L4, L5. And I believe the new, I don't remember what I did. I think I left the ramp and the, I think the new splitter is also actually like the straight belt. But the interleave case just doesn't work when you're curved. So it would probably be better to just make them all non-interleaved. The interleaved is a little easier to do the math when you're doing all the math in line. But if we stop doing the math in line, we can do that. The second thing we can fix is passing around logistics chunk everywhere. It's basically a premature optimization. I think it's a correct optimization. It's an optimization I want. But maybe I don't want to do it in advance. Maybe I want to, while I'm getting the whole system designed and working, I don't want to prematurely optimize that part. If you don't pass around the logistics chunks, then you always need the global coordinates because you have to look up the logistics chunk using the global coordinates. Currently, there's a mishmash of both local coordinates and global coordinates, local coordinates being relative to the chunk. And it's not documented, it's not clear, there's not a good convention to show that. I just have to know it when I look at the code. And I even have places where I store the coordinates of something in a different chunk relative to the local chunk, the local coordinates of a different chunk, which is just crazy. Again, all this is probably good for performance. It keeps us from having to keep doing these subtractions and additions to convert between the coordinates internally to things. But it's probably really a premature optimization in terms of being able to manage the complexity. Somebody's asking, you could still run the simulation independent of the chunks. Not really, right? Because the chunks are interacting with each other. And so you can't just like queue up and say, this thing missed 100 ticks. So when you load it, process it for 100 ticks, because it has 100 ticks of inputs that it needed to be getting. And you don't know what those inputs would be without simulating the things next to them. And so if you like independently load each chunk and run it for 100 ticks, it'll never interact with the things next to it. So there's really no good solution to that other than actually having them loaded and really ticking them. You can fast forward your ticks of a whole system at once, but it really needs to be a whole system. So if you decoupled and you loaded a remote factory all at once, you could then run that remote factory for all the ticks it was missing. But it may have missed, in a Minecraft style game, it may have missed an hour's worth of ticks, which is a lot of ticks. And if you did the train decoupling thing that I would talk about, the train never dropped off the ingredients it needed, and that hour of processing that's going to do is not going to accomplish very much. So I think that's not a path that's worth going down. It's just not really going to work very well. But you definitely can do this independent of the graphics. The intent is definitely that like the graphics are only keeping, 500 blocks around you loaded, but the factory can be keeping 10,000 blocks around you loaded. It's just the 100,000 blocks or the 1 million blocks. Like at some point you run out. And the argument is, one possibly is, no, you never run out. Like it's up to how much you can keep in memory. And you let it slow down if it gets too slow. And if it doesn't fit in memory, you crash or report you don't let them put down that object. It's like that would make the factory too big. That's definitely an option. I think it's better in a Minecraft spirit to let you go all over the world and make all brand new factories all over the world. And when you're in Europe, the factories in America aren't running. Like, I think that's actually reasonable. The question is where exactly is that size threshold, and can you do the decoupling, or can you live without the decoupling? You're in Europe and the things in America aren't running, but the things on the west coast of the things on the east coast of America are still running, and they're running partially incomplete. And as I said, everything is self-synchronizing. I don't think that breaks your factory when you do finally load it, but it is just weird. Okay. And I may be answering too late. Like people may be, the Twitch stream synchronization may be interfering with that. And that's fine. Don't worry about it. If I re-explain something that you already got, that's just the life on Twitch. All right, so what else do I need to refactor? And then refactor belts to work the same, to use shared logic as much as possible, except animation. So we expect the animation system, when objects move off of one belt onto another belt, they need to do kind of a weird trajectory. And currently they just pop. And there currently is a certain amount of animation. Remember, the whole idea is that they're only ticking every 16 or however many frames, and they animate in between those frames between these discrete states. And so the animation wants to go and say, oh, I can see this object is going to end up on that belt at this point when I finally tick. So in the 16 frames leading up to that, animated on a path that gets it there. And we're not doing that currently. We're not going to fix that anytime soon, but it's there as an option to be fixed. We do that correctly for the curved belts, animating across the curves. Like that's an example of the idea. And we do a little bit of it. We allow the things to move off the ends of their belts to where they're going to land. We just don't get them to exactly the right place where they're going to land. So they always pop a little bit. And that can be fixed with animation. The animation might have to lie about the speed, get it to the right place at the right time might cheat the speed, and that's okay. We can also ship without ever fixing that. But that's an option. So example animation, which can be unique for each type. That's just polish. And this is the issue that I saw that I'd like to fix. To fix it, I absolutely have to do this. And if I do fix these things, that will make life simpler for doing this. So that's the plan. I don't know if I'm going to get through all of it. Could also do player specified loading. Yeah, that's a good point. Yeah, you need an interface for it and stuff. I guess you could actually make an object in the world, which is like I was talking about with the Minecraft mods. You could just have an explicit object, that keep this factory loaded object or something like that. And it's up to you to deploy it appropriately. I think by default, I would like everything to just always work, to feel like they always work. But at some point you hit speed limits. But the thing I pseudo-linked to, the Factorio playthrough, that I pseudo-linked to it in chat earlier, is a good example of like just relying on everything to always be working and yet being pretty big spatially. It's not necessarily a big factory in terms of the amount of stuff being processed. He's just taken a normal factory kind of and spread it out really far. And that, I think, is worth handling. And that means, either supporting a really big radius or just supporting, not tying it to a radius, tying it to the amount of complexity in the factory or something, allowing a very big radius, but reasonable complexity factory to still stay loaded. So that's the goal. The goal is this one, and I gotta do all these things on the way to it, I think. I should do all these things on the way to it. So first thing is that our straight belts are currently interleaved. This is gonna be all over this code. Straight belts are currently interleaved, and I want to de-interleave them. Now, fortunately, we don't currently serialize the factory. We serialize the blocks and rebuild the factory when we load. And that's good because I'm not going to touch the blocks. I'm going to totally change how the factory works. If we were serializing the factory, this would all break. And eventually I'll serialize the factory, but for now, we're not. Okay, so belts. Split belt. Okay, so clearly the split belt needs to split the left and the right independently. So split belt raw is just... Oh, but these are STB arrays, so that does the right thing. Yeah. All right, so what is this doing? It's copying off the... A items plus a len. How is this? Wait, is... Oh, items per belt already has belt sides. So I did some code. Oh no, I used items per belt side in a bunch of places that could have been items per belt in the new code that I was doing. Right, so items per belt is actually what we don't want to use almost. Very often we don't want items per belt anymore because that's always going to be dealing with interleaved data unless it's just being used for size. So that's a good example of it here. So items per belt. Okay, so B len and A len are the new lengths. This is redundant. The lengths are also stored in the STB array, but that's okay. These are the raw lengths, and these are the raw lengths in blocks, and the STB array stores the item count. So that size is still correct, but now it wants to become interleaved. And then this is about to become, so because it's interleaved, we just shorten this array, and they're already in the right place, but they won't be in the right place if they're not interleaved. Right? They're currently stored like this. And so if you want to move these out away, you just shorten the array and 0, 1, 2, 3, 4, 5 are correct. Under the new scheme, they'll be stored like this. And when you split off the ends, you have to split off these. And that leaves 0, 1, 2. But the new packing needs to be 0, 1, 2, 3, 4, 5 to fit in the shorter array. So this is the correct length. And we have to do 2 mem copies. The first one, so we're going to want a function that tells us static int right offset. No, left offset. The right offset is always 0. Right offset belt run a return a error len times items per belt side. So the length of the belt, so that if it's one block, that's 4 items long. So then we want to memcopy to be items. So the right side, starting at a items plus a error len times items per belt side, not a len. Oh, a len. Yeah, we've already shortened a len. That's why that's a len. And then count is b len times items per belt side times the size of, I'm going to use that multiple times, so let's just stick that. So now we've copied out 3 and 4. Into B. And then we want to say memcopy arrow items plus left offset of B, the items plus left offset of A, and then we want to offset by the same amount that we did here. And we're going to copy the same amount of data. So let's line these up because they're actually very similar. All right, so now we've copied all the data out from A to B. Now we need to compact through this packing here. The 5, 6, 7 have to become 3, 4, 5. So we mem move the old left offset, which we can't get anymore because we updated a len already. So it's plus num a times items per belt side. That's the source. The dest is, in fact, left offset. And the number to move is a len times items per belt side. And then we reset those. I think that is correct. Check in chat. Yeah, exactly. The idea that you can load a chunk and do the processing necessary works as long as chunks are independent. Even then, you can run into that sort of LOD problem I was talking about for the traffic simulation, that if your game is very complicated and you build lots of unique little simulations that are private to the chunk, you still can have problems LODing that, of getting the correct behavior when you fast forward. But if things just like have an exponential decay, a randomized exponential decay, then you can run a different randomized exponential decay sim that just does it in one tick and isn't exactly the same, but is basically the same. You can also figure out how you can do the math to compute exactly how to do it exactly the same. But since there's a random number in it already, it doesn't matter if it's basically the same, to within, 1% or something like that. Nobody's going to exploit the 1% difference in the chunk being loaded and not loaded. I mean, you never know. People exploit all sorts of crazy things, but a 1% is pretty hard to exploit. Okay, I think that is correct. Unfortunately, we have to change all of the things, right? This is one of those changes where I don't know what a good way to deal with that problem is. I just change all the things. It could be that there's something you can do to do it incrementally. I don't know, keep 2 copies of the data and only change half bits of them and then compare that they're in the same state after the ones that you are doing. I don't know. But that is why I did have these multiple steps. I'm not going to try to do all of this. Like, what I'd really like to do is refactor the belts to use shared logic, and to do that, make the straight belt interleaved, because this is going to give me a lot more work potentially to do, having to de-interleave. So one of the things is that the curve thing already has de-interleaved code for handling the tick, and I'm going to either have to, if I do it in this order, I have to make the straight one de-interleaved without sharing that code. I might cut and paste that code and just try to use it though, and then merge it later, because then that might be easier than rewriting it. Yeah, I do mean rewriting it. So here we're splitting a belt. So eventually we're going to copy the data, I assume. No, we never copy the data. Oh, split belt raw, which we just wrote. Okay, great. So we don't really have to do anything here. We only care if it touches items. So we look for things that touch items. Oh, here we go. Merge run. So we have a logi chunk and 2 belt runs, I and J. And so this is just the opposite of what we just did. We need to, it just does a single copy, and we're going to need to do 3 copies, exact same way. So it's just going to be these in reverse, in fact. So let's grab those. Where it was a mem move. Okay. So we need to resize it to be larger, which we do right here. And then why do we stick the same variable? We are only using it once. Okay. So we have to do these in the reverse order. So first we have to, no, wait. Yes, because we're merging, right? So first we have to make room. So we have to move these this way. Are we merging into A? Where's the old one? Mem copy. Yeah, we're merging into A. So we have to move. Have we updated the lengths yet? No, we have not. We do that later, which makes this correct because, okay, so int total equals a1 plus b1. This is the a and len and b len are set to the same thing they were set, because we first set it in split, we first set it and then copy. And so when we reverse that, wait, we first set it and then copy. No, so they're not right. Okay. It wants to be the reverse order. So we need, yeah, a len is the total. Right, we do, and we do revert. So first we tweak their lengths and then move the data. So here we want to move the data and then tweak their lengths, which is what we do. We move the data, then we tweak their lengths. Okay, so the lengths will be the right lengths at this point. Okay, so I reversed this one. I haven't reversed these. So Oh, whoops, I didn't copy that. All right, so now let's look at what code I've just written and make sure it makes sense. So we take the left side of A's current items. Shouldn't it be the left side of A's current items? No, right. We're merging. So we want to move the left sides of a current item. So this doesn't work to reverse. So my argument that the lengths were already updated isn't correct. I don't know why. We want to take, oh no, right, because mem move, I'm thinking mem move is in the opposite direction, and then it actually is. Okay. Okay, right. So we take the current left items in A, which is that long and starts there, and we move them. We've already set the length, so there's room now. And we move them to the new left side start. That makes sense. Then for the right side, we take the current left side start. That doesn't seem right. Oh, this is right. Right. We take the current, the old left side start is where the expansion starts. So that is correct. That's where the expansion starts. I'm not going to explain why. If you don't follow anything that's going on here, I don't know how to explain it clearly. That's reasonable. We need to get the what do I mean by interleaved? I just explained this. You just missed it in the chat, in the stream like 10 minutes ago or something. Do I still have the picture there? Yeah, this. The two rows of contents on a belt are stored like this, left and right, left, well, right, left, right, left, right, left. And I'm switching them to being stored this way. Interleave, non-interleave. The same as like with stereo audio samples. That's the thing it resembles the most. So then the new left offset plus the old stuff we had, move the left side of B. Yes, that looks good to me. Then we do that, do that, do that. None of that changes because it's only reference to items that changes. Zeroing them all, that's fine. All fine. Okay, here we go. Belt slot is empty next tick. Slot -2 is assuming interleaving. So that means this code doesn't work for curves already. Which is an interesting question. Let's see how this is used. A turning belt feeding into the target belt. So that shouldn't work if the target belt was, oh wait, are curves still interleaved? I thought curves weren't interleaved. That's why I'm doing this whole change. I thought I looked at this code and said they weren't interleaved. How is this ever going to work? Like that looks like it's, how do alternating curves work if curves minus J. No, they're not interleaved. Look at this. We're moving them along one by one. So I don't know how this code actually works because we do have don't we have that? Don't we have cases with curves feeding curves? I don't understand how that ever works. Well, maybe it works and I'm misunderstanding the code, but at this point I don't care. I'm just going to plow ahead with the plan. Maybe since I'm only using that for allow new frontmost to move, maybe in the end, I did everything two different ways here. You can see there's two different ways mobile slots is decided. And maybe the other one fixes it. I don't know. Okay, so now we only look back one slot. We don't mask. Wait, why? What is this doing? Oh, mobile slots. So we have to actually explicitly pass in the side. And we don't do 2 times. Oh, we can't do this test. It's side times len times items per belt. Okay, so here's the problem. We need to know that offset for each side without doing that calculation everywhere. Right, we have this left offset, and implicitly we have this return 0, and then implicitly we have static int offset for side, run a inside if side equals 0, return right offset. This is effectively something we're relying on in some computing in some places. And in the old code, it was very easy because the offset per side was 0 for both of them because they were interleaved. Or it was 0 and 1, you could think of it, which is the same as side. Now we need this function, and that's a little expensive to compute everywhere. But I think we'll just use that for now, right? We're refactoring. We can make it inefficient and then go back and make it efficient. So what was that function called? Belt future something? I don't know what it was. Here it is. Belt slot is empty next to it. Okay, so what this is trying to do is test whether a given slot is mobile or not. Slot is mobile, the slot side. So that is slot. Not sure why it's slot -1. Why are we subtracting the 1 everywhere? Oh, yeah, except I don't need to do that. B mobile slots is not. Yeah, that's all fine. It's just that. Target belt. This is using target belt without passing target belt in. And it needs side. All right. Find items. Okay, this is inside the curve. Yeah, belt turn tick, so I don't change any of that because we're not changing that code. Splitter, we're not going to touch. We're just not going to worry about making splitter work. And then, okay, belt tick, here we go. All right, 0 the items. Wait, where are these variables declared? Oh, here. Target left start. Oh, this code used to try to handle turns. That's interesting. Oh, I see. Handle output to turning belt. Compare kill to straight hit right. So this is that thing I was talking about where it didn't really seem like it made sense. Right. Okay, so this is trying to handle that. And so if it's a turning belt, it uses long side, short side. And this is one of the things that we'll have to figure out how to handle. The long side and short side are the same offset thing that I was just calculating. So if it's not a turn, the left side is left offset of TB. And if it's the right side, it's always 0. So that code is fine. This code is not correct now. The len -2 and len -1 are not right. Len -1 is correct. That's the last left slot. But the rightmost slot, see how many places we use len -2. A few. So let's go ahead and store that in something. Int right end slot equals the left offset of belt run -1. So that's the right end slot. And as long as we're cleaning it up, let's go ahead and do this. Where did len come from? Is that computed up here somewhere? Yeah, I wish I'd named it something different. All right. So we swap to the right end slot. So here's a thing we can refactor. We're doing these swaps everywhere. And this is the left end slot. This is right end slot. Just look for more len -2s. And you can see how this code can now be shared too with other things. It could even be shared with you could even share this between interleaved and not interleaved, in fact. Okay, and here's where we start processing the left and the right sides independently. So now we go back and find len -1. It's the right end slot. Okay, now let's look for items. So is item pos correct? Item pos is probably not correct. Wait, I'm in the wrong. No, I'm in the right one. Okay. That's right. Target right, target left. We set correctly here. Here we don't compute those. We compute item base and item pos. Item base. What is pos? Pos is the point on the belt. This is point on target belt. So we get to that point. So this is all assuming interleaved. We're going on to the left side that we can see. And so the item pos is the item base, which is all along that way, then some distance into it. This is, oh right, I remember this again. Then times 2, this is the part where we're handling that stuff. So now we want to say slot is pos times items per belt side plus that, which is the same as this item pos calculation basically, but we're not going to do the times 2 because we're not interleaved anymore. So that's the slot number. Sorry, that's not the slot number. That's the position. So that's item pos now. Then the slot number is left offset of target. This is the target belt, right? Or it's the target belt called TB. The slot is that plus item pos. Voila. And now where we use item pos, we want to use slot because we're going to try to use a consistent terminology where slot is the array slot and pos is the physical position in the world. And now this becomes slot. I'm not sure why that uses -1. It's the side. So the side is the 1 because we're going to the left. We're going to TB's left side. Oh, but this took a pause. That was the whole point of changing belt slot. Belt slot. The whole trick I was relying on here was to take have this one take a pause. That was why I didn't need to do all that complexity. I could just do that. And you can compute slot from pause, but let's not for now. Let's try and keep this simple so that we don't break the refactor. We're going to have to fix these. Item pause. This is the turn tick that I was saying is already seems broken anyway. We might leave this broken until we merge them. That's the splitter. We're skipping the splitter. Okay, here's the... Oh wait, this is still the splitter? Yeah, because the splitter had a ton of cases. Okay, now here we are. So now this takes the slot and the pause and the side. Okay, that should be better. Now the pause, we want to move forward. Item pause equals pause times items per belt, no, slot. Yeah, oh, it's item pause, not pause. This is base pause. This needs to be item pause. Okay. So we still have base pause. So we take base pause times items per belt side. Then we go plus items per belt side to get to the other end of it. And then we move back by oh, these are backwards actually. This is the left one. The left one feeds to the far end. Well, how is this computing the far end? I don't see that. We do that. And we say -1. And then for this one, we just say item base plus 1. Oh, I see. I've made a total hash of this. Base pause times items per belt side plus 1. Let's try that. And then that's item pause and slot equals right offset plus item pause. And then this is slot. This is slot. This is pose. Slot item pause side. This is the left side being allowed to move, and this is the right side being allowed to move. Why were those backwards? Did I reverse these while I was writing all this code? I must have. Wait, they both say right end slot. Why do they both say right end slot? I must have broken something when I was refactoring this. Right, this was that lenmise2, lenmise1 stuff. I must have typoed one of them as right end when it was left end, when it was lenmise2. I can't tell which ones correspond to which ones. Okay, well, assuming the break, then these were len-1, which should have been left-hand side. These were len-2, which should have been right end. So it looks like it used to be that this was the left end, which is why I got confused about why they were, which ones they were being assigned and why this was backwards. Okay. And then this has to compute +1. And this one is. Why is that divided by 4? It should just be that. I mean, I know I was thinking of something, but let's keep it simple. Let's do that. Plus the t. All right, let me see what we've got in chat. Pasted in right when he should have pasted in left. Okay, apparently you guys are incredibly lagged compared to me. Or that went into chat and I didn't notice it ages ago. I guess that's possible. So let's look at what the logic is here. The left side should go to the front and the right side should go to the back. The right side is sub-0. So side should be sub-0. This side should be sub-1. This is 1. This is 0. Right, left. Okay, I think I fixed that now. And let's not have that. Well, that should always be true no matter what. It's the slot, not the... Slot should always be valid. All right. So now we fixed this case. We fixed this case. Now we have the same case in the opposite direction. And this is an example of the kind of redundancy I'd actually like to remove. I'd like to not only make this not have splitter have 6 of these and curve have 3 and straight have 3. I'd like there to be 1 that is just parameterized in some way. And this will be more efficient, probably, though fully expanded out. Making that stuff be kind of a little more indirected will probably be less efficient than explicitly handling every case, but that's okay. So item base, how did we do it up here? Base pos. We renamed that just to catch if we are still using pos anywhere. We don't want to be using pos anymore, so we rename that to catch that. So this becomes base pos. Okay, which one are we handling first? We have the same problem here. This is the left. I'm still dying to hear how a modern Visual Studio would have prevented me from accidentally typing left instead of right. So this is base pos times items per belt side. And this is the 0. This is the right side. So we add items per belt side -1 to get to the far end of it. And yeah, this was offsetting by 0. Okay. And then the slot equals 0 plus item pos. Slot. And the item pos is now base pos. That's items per belt side plus. Did we say 0 in the other one? +1. Yep. Okay. To match the illustration. I don't know if that's right, but that's what the illustration shows. I think that's actually right for eventual animation simulation. That is actually what you want. Slot equals still the right offset plus item pos. That one still says right. This becomes slot, comma, item pos, comma, 1. This becomes slot, comma, item pos, comma, 0. Okay, I think that's that. Might have typos, might have bugs. We'll catch it when we try to run the sim. On we go. Okay, now when we move them down, we don't multiply by 2. Like so, which one? This is doing the right side. All right, so we need an extra variable here. Left base. Left base equals left offset of BR. Right, okay, so first of all, the 2 times 2's go away. The offsets all go down by a half. So if times 2's go away, offsets go down by a half. Then we can look at the code and double check that it makes sense. And this now goes from len minus 1. And it's len. Len is no longer correct. Len is the old, the full length. So this goes from br len. Okay, so what we're saying is if the one at j is empty, it should be len minus 2, right? It started at len minus 2, but, oh, right, it was multiplied by 2. So it is the right len. I'm confused. It's items per belt, not items per belt side. I want items per belt side, right? Why is this only... How did this ever work? It's multiplied by 2 here. That can't be right, can it? Oh, yeah, we can use len right here. Now it's items per belt side. Okay. Fuck me. All right, so len minus 2 is correct. Because then we look at len minus 2 and len minus 1. Len minus 1 is the last one. So we check, is the last one empty? If the last one is empty and the one before it is not empty, then move the one before it to the last one and empty the one we just moved. Count down, repeat. Looks legit to me. Okay, then these, we already deleted the times 2's. All the offsets get cut in half, so this becomes 0, 1, 0. That becomes 0. And that becomes 1. And then we have to add left base to all of them. So we could share these loops, right? We could write this as a generic function, which is something we'll come back and do. I want to just get it working, and then we'll come back and clean this stuff up. Right? They just have a different left base. One of them has 0 as its base. Oh, I don't want to add left base to that one. Did we ever get an answer to how VC6, or how later the VC6 would fix it? Nope. Okay. And then items. Okay. So allow new frontmost to move. Now we must check if item len minus 1 is allowed to move off the belt over the next long tick. Okay, right. So we walk down the items. Similar thing. The len is the correct len. So this loop count doesn't change, but this offsetting does. So it's the right side, so we just use j. And then for the left side, we still have left base around, so we can use that. So this becomes left base plus j. So again, this is an example of something where we can just replace this with a single thing that can operate on both sides. And then we're looking at the first item, so that's 0, and this one is left base. And I don't care about making the global hack work. That's an old thing that just spontaneously generated stuff onto the belts, which might be useful for debugging still if it turns out there's bugs. So maybe we should. Go ahead and fix it. All right, that's all those. Let's fix the compiled errors in what we've got so far. I added that size T above. Oh, that's unreferenced. Okay. Okay, I have to expand all these. So item pos is still the slot for this function. That's fine. Then we need the actual pos. Wait, this is interleaved still. What function are we looking at? The turner. Oh, right. This is assuming it's... No. What? Didn't I fix this code? I skipped over it because I thought it was already correct. Target is... Well... I skipped this function or something because I thought it was already correct, but it's totally wrong. Okay, the turn itself is interleaved, and so that's already being handled with the left start, right start stuff. but it's still assuming its target is interleaved. So it's got this stuff, which is totally wrong. So if the target is a turn, it does this computation. Otherwise, it needs to say left offset of target belt. Now, as long as it's using those variables, that's all okay. Item pause. This is that same item pause calculation we were just looking at. It's going to be all exactly the same code, except the source is different because it uses right end and left end. Oh, and interesting, it's right end and left end -1 in this function now. Great. Because I made this a non-inclusive endpoint. And in this function, I made it an inclusive endpoint. I gave it, yeah, I put the -1s baked into the variables. All right, tell you what we're going to do. We're going to let the curves be broken, and we'll fix them when we refactor it, because really refactoring all of this stuff again just doesn't seem worth it. We'll see. We'll see if I can test it well enough with the curves being broken. So we'll allow this to be bogus. So and if it doesn't work, I'll come back and fix it. I mean, if that's not good enough, okay, I can always come back and fix it. So and this is probably the splitter. All right. Because that's just a waste of time when I do merge them. And I talked about that a little bit, that I was like, oh, I'll just waste the time. But now that I'm actually there, I don't really want to waste the time. All right, so now we're looking for more items. Remove item from belt, and we're passed in a slot. So we need to look at the caller and see how it wants to work. Does it want to be passing in a slot, or does it want to pass in like a position and a side? So this is a picker, and it's getting back a slot from this function. So it really does want a slot, so it just doesn't have to mess around. All right. So we really do want a slot. So then we have to say, we need to figure out which side we're on, and we need to figure out what the position was. So we say, so we say offset equals left offset of slot of B. If slot is less than offset, offset equals 0. So offset is effectively either the left or the right offset, but this is a more efficient way to compute it than calling that function. Which only works if you already have the slot as a slot number, specific to having a slot number. So then side equals offset not equal to 0. And pause is slot minus offset. I believe that is correct. Try and remove item from belts. It has to be of these two types. Okay, sure. We just call the thing through. That's fine. Add item to belt. The slot has to be 0. We do that, and we're going to update mobile slots. Okay, so we got to do the same thing. Set equals left offset. So let's make that a function. int offset for slot belt run asterisk b offset equals left offset of b if slot less than left off and our base is 0, otherwise our base is left off. Offset equals offset for slot b comma slot. And then we do that here. Whoops. Offset side equals offset does not equal 0. Pos equals slot minus offset. Then here we look through the items. So we need to actually say offset plus j. Try adding list of belt. It's just looking at that, so we don't have to change anything. Find belt slot for picker. Here we go. We have to get interaction pos. And then we need to know the side. Okay, which we can hit here. And then that. And then offset for side, is that what it's called? Right, look at the offset for side for the belt run and the side. And the slot is pos times items per belt side plus the start offset. So it starts with the start offset. Let's always do that first. And then however many blocks along it is. And then do we add something else to do the interaction for the belt? Dist. Looks like dist. That looks right to me. All right, and then do we directly call items? This is inside an if 0. That's the old splitter when it was a belt machine, which we can kill now because we did get it kind of working as not a belt machine. And it's no longer a belt machine ever. Okay, here's some direct accesses to items with the balancer. So this actually works anywhere on a belt. That's interesting. Because it's not a belt. It's a belt machine, not a belt. So it doesn't need a belt run of length 1. So we need to say left off equals left offset of BR. So the right item is let's call that pos for some consistency. Well, we should make a different name to handle all these cases. So it's pos times items per belt site. Right, this was the one where I was like, oh, I could have used items per belt. I didn't even remember I had that variable. And then we want 1 along there, and then it's on the right. And here we want left off plus pos times items per belt side, not times 2, plus 1. And that final plus 1 is the left off. Okay, that all looks good. Then these are probably just the same 2 variables, except with cur side stuck in. Okay. I maybe just want to handle these separately instead of trying to share the code. Although I should, it's going to be, the problem is making a code change in the middle of refactoring is kind of bad, but the logic for them is, I mean, I guess I could, make this work. I mean, I'm just doing a swap between those 2 sides. Maybe if I just swap them. Oh, right, but I don't do it if the state is the current state. So this swap still works if I put in the correct coordinates. So curve side, that's all correct. Int left slot equals left offset. Yeah, okay, so this works. The swap doesn't need to do them in the right, or it doesn't need to know about curve side. In fact, it doesn't. I use the curve side in the assert, but I don't use it in the swap. Okay, that's all good. All good. So the left slot is BR. Oh, I already have left offset computed. It's left off plus pos times items per belt. It's the same thing that's already up there, plus 1. And int right slot equals 0 plus pos times items per belt side plus 1. I just can't do the assert because I don't have a trivial programmatic way to do that. I can, it's just a whole long line of code. The curve side does not equal the, then we just say br of items left slot, and then we stick right slot over left slot, and then we say right slot and right slot. Okay, I think that's correct. Lost the assert, but that's okay. And then items. We want to search for items again. Have we wrapped? No, we have not. Picker. We just used slot directly, so that's all fine. As long as all we're checking, as long as we're not moving things, as long as we're just using a slot, a value that we got from somewhere else, it's all okay. Here we're computing one, so we have to actually do things correctly. Stepping by 2. This is rendering it. Do we do curves specially? How do we handle curves here? Oh, right here. Okay. So curves are already handled differently. We want to go we'll use the same variable we did the other time, times items per belt side. So we have to split this loop in 2. Or we could, actually, let's leave it as it is. Okay, so this becomes less than len. That's, which is actually left offset. We know that that's left offset. So we can do this. E plus 0 is unchanged. E plus 1 becomes E plus len. That should be correct. But here you can see me handling the right and left cases independently for the curve. But they have different curve shapes, so it's actually better to do that. And then we have the debug renderer, and I don't think it ever looks at items. Okay, so we got all the way around. Now let's get all compiled. Okay, now let's run it. I'm sure it won't work. We do expect the curves to be broken if anything's working. Nope. Okay, look at that. It's just outputting blacks onto somewhere. Somebody is just generating black things, which I don't even know how you do that. How do you get a black blob? Is that a 4 or a 0 or what? And I don't know where they came from. Okay, we do have a splitter trying to run, it looks like. So let's make sure that's just a straight thing and save that. So there's no splitter in the map anymore. And I expected curves to be broken, but these things got around the curve somehow. The bogus black ones. Oh, we actually want to connect this. So that they get around to the far side. It actually wants to be a turn so that these, well, but I don't have any way to place a turn currently. We want it to be a turn so stuff stays on both sides, but because that's all going back up at this point. Okay, it's mostly working though. Just don't know where those black ones came from. Let's run it again and see if I can see where they start. They seem to be starting there, which is a weird place to start. Is that a chunk boundary, maybe? Maybe they're happening at chunk boundaries? Oh, I forgot to save it with this change. Save. So I think that's happening on the straight belt tick. Somebody is computing the wrong thing or copying from the wrong place. Goes down to 0. Left base plus J. Well, which side is it happening on? Is it only happening on one side? That will simplify our life. Oops. Where? There it is. It looks like now it's in a different place. Looks like it's happened on both the right side and the left side. Those happened on the left side, both sides spontaneously. It's happening differently here, though. It's not being consistent. It's on the right side up here now. So I don't know what that means. Uninitialized variable. Who knows? These must have generated spontaneously. Like this still just doesn't even animate correctly. Don't know why. Don't know what's going on there. This transition is working correctly, though. Oh, things are popping back sometimes. There's some kind of animation glitch. Okay, yeah, it's not updating correctly whether it's allowed to animate next frame. That's incorrect on that direction. That's a right turn. Let's take a look at that. That's a concrete thing we can look at. So a right turn, that's case 3. No. Yes. Neither of these animation systems were being set correctly. So which is this? Belt slot is empty next tick. So we may have gotten that wrong. So I don't know why these are all slot -1. I mentioned that. It doesn't make sense that they're slot -1. Oh, it's this slot. We're looking back 1 to see what's coming to that slot next time. So we look back 1 slot. If that slot, we're allowed to look at it at all, then we look in that slot, and if it's empty, and if it's moving, so we check whether that position is in the mobile slots on the target belt side. That. If the slot is invalid, then we want to know about the slots coming into that belt, which TB has already computed for us using this. Okay, so the side is the target belt side. I might have gotten that wrong. Yeah, I was saying 0s and 1s and matching them, but it's supposed to actually be the input side, the output side. So this should be 1 and 1. This should be 0 and 0. This will only fix one side, so not sure. This should be 1 and 1. This should be 0. This is the splitter that I don't care about. 1 and 0. 1 and 1. 0 and 0. So that's not going to fix it, though, because it's only fixing half of the cases. I'm only changing half the cases. Okay, so then where's the black thing coming from? We're moving some garbage into somebody. We're not merging or splitting. We haven't tried doing any merges or splits. Oh no, we are, because that's what happens when you load. You merge. It does do all the merges. It's not testing any splits though. Splits happen when I delete things. Everything seems to be moving correctly. That's what this code is doing. And then we're checking this. So if allow new frontmost to move is set, that's what we just set up there. Otherwise, we search to see if the whole thing is mobile. If the frontmost is allowed to move, then the whole thing is mobile. Otherwise, we check to see which one, where the first empty slot is, and that tells us which ones can move. And if force mobile is set, then the whole thing is allowed, which I think is redundant to allow new frontmost to move, maybe. Where does force mobile come from? Yes, that seems like that should be redundant. Like, I'm not sure why we test both of those. But yeah, that's a mess to be resolved another time. This all seems reasonable. I just don't know where the black ones are coming from. Could it just be a rendering glitch? No, I don't think so. Like if this were computing a wrong thing, it could be, but he goes up to len, which is items per belt side. The largest we do is len plus e, which is items per belt side times 2 minus 1. It's all legit. Use e plus len everywhere. We don't have anything inconsistent. Not sure where this lives. It's not in here, is it? No. Okay. Let's see what the value actually is. $205 uninitialized memory. Yep, CD. It's part of CD. It's the left side. It's looking at the left side, the very first slot of the left side, and it's uninitialized memory. But we didn't change the size of anything, so all of the mem sets should still be memsetting the same amount of memory. So why would that go wrong? Oh, that's like super annoying. Yep, and only half the memory got initialized. How did that happen? Oh, we don't memset all the memory. When we do a merge, we just copy. So the merge must be broken. Right, which puts us in a bad initial state, but then once it's running, doesn't affect anything. So this must be wrong. And in this particular case, it's the left side going wrong, but it seemed like we were also seeing other things happening. Okay, so we assume that the initial data is memset, because it is. All the initial data is memset. We take what's currently on the left side, which is items plus, take what's currently on the left side, items plus left offset. We move it to the new left side start. I left out times item size here, but it doesn't matter because item size is 1. Then we move B over. All right. Oh, it can be 0, of course. All right, there we go. Uninitialized memory. Is it after? It's after. All right, so something here just went wrong. All right, where in the array is it? I is 8. A line is 9. So that's somewhere in the middle of the right side. Because that's 9 times 4. The length of the overall array should be 9 times 8, or 72. Oh, none of these are being multiplied by items per belt side, maybe? No, they are. They're all being multiplied by items per belt side. Let's check what left offset of A is. Oh, this is after I've incremented A line. 36. Okay, that's correct. Don't know what the old value of A line was, but we can compute it. It's A line minus B line, so it's 1. So it used to be 1. Okay, so the first 4 slots were from A. The next should all be from B. And they go wrong. We only get 4 valid slots got copied over from B. So there's some missing times items per belt side, maybe? Nope, there's that. Okay, the old A line was 1. So this is supposed to mem copy. This should be plus 4, plus 0. 8 times 4 is 32. Should have copied 32 bytes from B items. These are all zeros. Why does this not copy what I think it's supposed to copy? A line was 1 times 4. How does that not work? What am I missing? What am I forgetting? The comments are wrong, but How is this line wrong? It looks right to me. What keyboard do I use? It's a cheap Dell keyboard, $10 Dell keyboard. All right, this is the one that may or may not have been the one that went wrong. A line is 1. Items per belt side is 4. B line is 8. Items per belt side is 4. That should mem copy 32 bytes. Item size is not 0. Item size is 1, right? Yes. A line is 1, so that should copy to 4 off. All right, so let's stick a value in B items 0. We'll set that to 33. And then let's set B items of 4 to 44. And now let's step that. And now I want to see A items of 4. Okay, and A items of 8. That copied. It did copy the value. And then that copied over it and stopped it with the 205. Okay. Left offset of A is incorrect. It's total times items per belt side. Yep, that's the bug. All right, let's see how this goes. All right, let's try breaking up a belt run here. Yeah, that's not quite right. And it broke this. This is no longer animating correctly. Let's see if it fixes itself. Oh, it's not going to back up now. Curves are still working okay. Are these working correctly? They are. I don't understand why they're working. I guess they fixed them actually, but I don't know why they used to work correctly. Maybe they didn't. I didn't notice. So there's still that glitch. But maybe I just want to merge all the code. Maybe I want to finish the refactoring and fix that bug. The main thing is that when I split it, it doesn't immediately go wrong. Like the stuff stays in the right place. This breaks, the animation system breaks, but it doesn't teleport the objects to the wrong places. Oh, there it did. It teleported them to the wrong place. There you go. Yep. Okay, so the split is also wrong, which makes sense because I copied the merge from the split code, so probably it has the same bug. All right. So we can delete these checks. And let's look at split run, and it's probably just got the same bug. Where's it? Split belt. So the problem was that one of these was wrong. So the right side so we copied the left items of B to the new Wait, we're splitting. Right, sorry. So we copy. We've already resized A. So we want the old. But that's the same as this one down here. Oh, but this has this extra plus A line. Okay, I think that's probably correct. So, Rastafaro, in yesterday's stream, I in fact retired my year-and-a-half experiment in using an expensive clicky keyboard and switching back to this because I like it just as much. So I didn't simply use the cheap keyboard because I don't care or etc. I actually tested, tried something different, saw no benefit. Nope, it's still broken. All right, I'll have to actually think about the code this time. All right, so the right side starts at B items. It's going to that far along. Split belt, we're about to shrink. We've already shrunk. No, we've shrunk len. We have not shrunk the array. We'll shrink the array here. So the right side, we take the right side of A's, the end of array of A's right side, and we move to the right side of the new one. Then we take the left side, the end of the left side, so this computes. No, num A is the reduced length. Wait. Num A is the reduced length. The old length we don't store anywhere. What? Wait, I'm totally confused. We can't use left offset of A at all. That's just totally wrong because we've already updated A len. And we can't use num A because num A is A len. Okay, so int total len. I think that's what we called it in merge. It's A len. Okay. So the old left offset is total len. And this should be total len as well, I believe. So that gives us old left offset. Excuse me. And then to old left offset beginning, or from the old left offset beginning rather, to the new offset, left offset. Oh, it seems very small. All right, let's try it. All right, we can actually do this one. Well, this one's still probably better. Wait till it gets nice and built up. Yay. Okay, it's still got that glitch. Oh, you can just rotate. That's true, to cause it to split. Yeah, that was weird. You could see that back propagate in a sort of weird way. There you can still see the animation glitch. Animation has not been computed correctly. You can see that one. The animation is, they didn't turn off the animation, which is mobile. I believe that's the mobile count is not being computed correctly. When it feeds into a turn, mobile count is not being computed correctly. And then what about this case? Yeah, there's a glitch here. So feeding into a turn to the right. I looked at this once already. Feeding into the turn to the right, the mobile count isn't being computed correctly, or the left is left, whatever it's called. The belt run thing, I think. We don't know which case is triggering. And I was saying maybe I'd just save that and come back to it. It's just a splitter case. Here's belt. It's the right turn, which is this one. So either this is wrong or this is wrong. But this looks pretty legit to me. This doesn't seem right. I don't really understand what that's doing. Isn't it somebody else has to decide whether our last slot is filled? It's when you feed into it that you know whether its last slot is filled. Doesn't really make sense to me. Last slot is filled is initialized to 0, and we only set it to 1 if we're not moving and it's full. If we're moving, then it'll always be empty. If we're not moving and the last slot is, I guess that's right. Yes, it's somebody else knows whether they're moving stuff into it. So this is whether the slot is filled if they don't move into it, which is how they decide whether they can move into it. Okay. Which is the feed the straight ahead on the curve case. Allow new frontmost to move. Comes from last slot filled next tick, which looked good to me. Did I not fix this up in the turn case? No, that seems reasonable. So it's possible that this is just broken. Let's test the theory that this is only used for animation. Check that the animation is, it's okay if the animation is broken. I just want to check that the sim isn't broken at this point in any obvious way. Because then that does mean it's just that thing that's broken, probably. Or something in the animation is broken. It means that I don't have to worry about this function except for its animation behavior. So I want to disrupt one. Yeah, there you see the animation break. And then it actually fixed itself, even though that input was broken. And now the animation is broken, even though it's moving. It doesn't know it's supposed to be moving, so it's still busted. There it goes. So who knows exactly what? That's that thing I was saying where there's two different ways it's computed, and I don't know why, and what a mess. Don't know if that's ever going to figure itself out. There it goes. Oh, now it's broken the other way. Okay. All right, so I think this is only used for animation. So I don't really care if I don't get it right. I think we can fix that up after we do the other refactorings. So I think maybe the simulation is all reasonable at this point. Is back to where it was. The animation is a little broken. I think maybe the sim is back to where it was. This still has that glitch that was expected because we just want to forbid that. It's too hard to fix it correctly. So you just shouldn't build that. Or the logistics system needs to ignore it, basically. You can see this is glitching because of the end. So there's some even more fundamental bug there because this doesn't feed to anything. So I should actually be able to handle that case. Logistics belt tick. It's got no target. What do we do if it's got no target? Allow new frontlist to move is initialized to 0. Mobile slots is computed by moving the things. Allow new frontlist to move is always 0. Then we scan along. Am I looking at the wrong function? I am. I'm looking at turn. I'm gonna look at the straightaway. Allow new frontlist to move is all 0. So this is false. Iterate, looking for zeros. Set mobile slots of 0 to the number to the slot that was the first 0, counting from the end. Left base. Is left base being computed somewhere? Left base, right here. Left offset of BR. I'm pretty sure the animation just looks at BR mobile slots, so all that matters is what value is computed here. We recompute it after taking the thing. We also recompute it. Somebody else tweaks it, I think. Right? There was this whole thing where the update tweaks it, which it probably shouldn't. I don't think it was split belt, but oh, here, remove item from belt now. Yeah, because this is happening during the tick, so you might have already ticked that belt. And so if you fill in a thing, if you fill in something, if you take out something in the region where the stuff is stopped, then the stuff can start moving. And if you put in stuff at the spot where the motion was allowed, if you put in something in the middle of a blank area, it just will start moving. But if you put something into the last slot that was open, which was this case, then you have to find where the new current mobile slot is. So this is using offset for slot, which is maybe the only place using offset for slot. So maybe I didn't get that right. So I wasn't doing it very seriously. I was just trying to show what the idea was. Offset for slot. Oh no, it was offset for slot, not offset for side. So this says, find what the offset is for the left side. If the slot is less than the left side offset, then it's before the left side starts, so it must be the 0 side, so it starts at 0. Otherwise, it starts at left off. Seems reasonable. Then what do we do with this? Position equals slot minus offset. Seems reasonable to me. All right, well, let's check it in. All right, so let's go ahead and check it in. Refactor belts to be non-interleaved. Some bugs. We'll retackle the bugs once we've done the other refactorings because the code will get simplified. All right, so the next thing I want to do is stop passing around the logistics junk. But that also means I'm maybe going to need to do global coordinates over here. So get logistics chunk. What is the function called? Logi chunk is the object. Oh, so maybe it's called get logi chunk. Nope. Okay. Let's keep searching for logi chunk then. Logistics get chunk, of course. Great. So this takes global variables. It returns you the cached slice in case you wanted to cache that. And so we're going to try to make a new system where we don't cache anything to start with. We can come back and cache things. So we'll do return logistics get chunk. No. Okay. Guess logistics get chunk alloc. That's all fine. Compute mobile slots is recomputing the mobile slots from scratch. Not sure what the... Is anybody using that? I didn't fix this function. I didn't even notice it. Somehow I skipped by it. Compute mobile slots. Yeah, we could do it in a bunch of places and I didn't fix it. I think. Or did I fix it and I just don't recognize it? No, I didn't. So what we're doing is in one iteration, we're handling both sides, which we had to do because it used to be interleaved. But now that it's not interleaved, actually we want to move both these up. Now that it's not interleaved, it's going to be clear to do it in two loops. So we need int left off equals left offset br, and len equals br len times items per belt side. Left off and len are the same, but let's not worry about that. And then we say if br items of j.type equals 0, br mobile slots 0 equals j, and then we need a fallback case, mobile slots of 0 equals 0. So if this turns into a break, then this becomes equals j, but that doesn't correctly handle the case when j gets to 0. Apparently we're setting mobile slots to 0 if there's 0 or 1 item. No, sorry, mobile slots to 0 if there are no items or only one empty slot. Then they're all set to immobile, which is a little bit wrong. It doesn't matter because the slot itself is empty, so you have a little bit of error slop, but it matters for feeding in the next item. So that's actually possibly a source of one of our bugs. So we'll go to the to-do list and say change mobile slots to be consistently inclusive or exclusive. Currently 0 has 2 meanings. So this has to be j less than 0 plus 0 colon j, which is I think the same code we have somewhere else. All right, and then we do the right side, or the left side, I mean, by saying left off plus j. We don't need blocked. And now we could call compute mobile slots in the tick function if we wanted. So this is just doing the same thing it's doing. That was just de-interleaving it. So let's go ahead and check that in. Although I didn't actually run it to be sure it didn't break anything. I'm not even sure what case was that I was calling this. Was that only in the split case? Because I thought that was actually working. Yeah, it's split. And then it's also in create, but that doesn't matter. It's always empty in create. Yeah, it's all a little broken still. All right, so what was I starting to do? I was starting to logi chunk. So we did a new get chunk. And we're going to try to get rid of everything that passes around logi chunks. That's the current goal. So here is the XYZ relative or global. It's relative. Do I already have a structure for this? Spec 3i. All right. So now we're changing x to be global coordinates. So we want to, the past in x is now global coordinates, but the code was assuming it was local coordinates. So we'll do that. Now it's back to local coordinates. So now we need to find all calls to split belt and change them to global coordinates. So we compile so it finds it for us. Here's one. You can see that's using local coordinates of that. And then, boom. But it actually still needs the local coordinates for what it's doing here, which is fine. That was the only call to split belt. All right. And then let's run and make sure we can still split belts. Okay, that all seemed reasonable. Destroy belt raw, takes a logi chunk and an index. I think in that case, it's okay to do it because the index is already logi chunk specific, so we might as well leave that. But we'll clean up the code while we're here. So let's revise our to-do. Get rid of except if passing belt ID or similar logi chunk relative ID. All right. I have two monitors and I have a solid keyboard. It's not a membrane keyboard, but it is a rubber dome. I shrunk. Yeah, well, I made a new machine. I built a new machine and reinstalled everything, so I configured slightly different. I don't remember what it was set to. Burp. So clean up input pointers to belt run. So this takes logichunk, XYZ, and a belt ID. But I think the XYZ, oh, this is commented out. So we'll leave it alone. Destroy belt. This is exactly an example of a function that shouldn't take the logichunk anymore. I think. We'll see. Equals get chunk. XYZ base. 3i base. Same thing. This can be redone. I can propagate this down into this code instead of subtracting it here. But for now, we'll do it like this just to make it the straightest path to changing it. Okay, and then destroy belt. We have to change the call here to use XYZ. Same thing. It's being called from the same function. Things should all exist. I forgot to delete the logichunk. Okay. This is what, update? Yeah. So now back to that function, destroy belt. And keep going down. Merge run. Okay, that's taking 2 belt IDs. So we'll leave it. Doesn't use any coordinates in it anyway, so we'll leave that alone. Create ramp. Does not take global coordinates. Does it use C? It does use C. Okay. So same thing. This is making it look like more work to do this. So maybe I'm wrong, but I think at the calling side it will be easier. It makes these functions more complicated, but these could actually be masks. They don't actually even need the base, so I could look at doing that differently too. And now the calls to create ramp. I renamed these. Calls to create ramp, lose C, and stop using relative coordinates. All right. Everything seems to be in order. Let's put a thing in here so it'll start faster when I load it. So you can see things going around curves faster. So these are here. Okay, so anyway, that all looks okay. That was create ramp. And then we keep going, create splitter. Create turn. They all have the exact same stuff. In fact, let's actually go ahead and do that thing I was saying. Just these are. There's a thing macro to do this, right? I don't actually need to mask directly, do I? Maybe I do. Everyone's doing it by hand. Oh, Logi Chunk mask. Here it is. I just forgot it, and everybody did it by hand after that. Logi Chunk mask. Wait, that can't be right. They have to be sub x, sub y, sub v. So we still have to change the calls to these to do the right thing, but do this one too. All right. So now I want to go back and look at all the calls to get chunk and see if they can all use this macro or if they're actually doing stuff, some of them. Nope, this can be that. If they're all like that, then we don't even need that parameter anymore. It's kind of clear to subtract from the base, but who am I to argue with not needing an extra parameter? Right. Why does this one warn and the other one didn't? The other one was a subtract. Did I have a cast here and I lost it? This is a mask. This one, it should be able to tell. Wait, the Logi chunks are not that big. What's going on? I thought the Logi chunks were a lot smaller. Oh, that's cache size, not chunk size. Jeez. This is a mask with a constant. It should at least be able to tell that fits in a UN8. How it could tell the subtract fit in a UN8, I don't understand. That's very odd. Oh, is it because it's ints to unsigned ints? No. Maybe. But they were subtracting ints. Yeah, this doesn't make any sense. I don't know why this one requires the cast and the other doesn't. Which now makes it less appealing, but that was totally arbitrary VC6ism probably. Okay, so now we gotta fix these. Destroy ramp return, we're gonna have to fix probably. Okay, that's all those. So we still have to create splitter. Destroy ramp return, sure enough. So the whole thing about doing this change is that get chunk is order 1. It's just looking in a direct map table. So it's not too slow, but it is obviously slower. It's slower in that. Oh, and I'm doing masks on ints instead of masks on unsigned ints, by the way. Hooray. Where was I? I was here. So so while this is getting slower because I'm not caching it, it is directly indexed off the XYZ, so it's not too slow to get it, which is why I'm willing to take this de-optimization. And like I said, I may put it back in. I may go back through and do all this, but I want to get the whole system a lot more close to done before I do that, so that I can not so much so I can profile it and see where it matters, because this is a kind of thing that matters everywhere to a certain amount, and it doesn't necessarily show up on a profile that well. But just so that I have all the code more stable before I do it is the point. So destroy ramp return. Now we've got to go fix these. Okay. Create picker, find picker. So that's create picker, and then find picker. We'll have to look at how find picker is being used and destroy picker is being used. I think those are just called from that same function though. Destroy picker. Yeah, so it's the same thing. Is find picker used anywhere else? No, it's not. So we just want to inline that. If we find it, all right. We have to actually build and destroy things to test these. Oh no, we don't, because it does create things when we do that. So all we have to do is destroy them. Okay, that all looks fine. How to create mods. For the texture on the conveyor belt that turns the materials 90 degrees. So the normal conveyor belts are just a scrolling texture, as you probably figured. And if you look at the, maybe it doesn't come through because I have this at a really low frame rate. It's only at 20 frames on Twitch. But if you actually are running the game, this stuff is animating at 60 frames per second, and this is animating at like 10 frames per second or something. Because it's just a series of animations. It's just, I mean, a series of textures. It's just like 8 textures or something. 4, maybe only 4. Because I couldn't think of a good way to do it. And this is an artist-friendly way. Now the other thing is, of course, that like a real conveyor belt, I don't know, they don't curve like that, right? They'll have multiple layers that shift over each other, like the belt at a airport. I don't know how they go around corners if they're flat. Do they? One thing you could do is you could just have one going one way and one going another way and have a diagonal intersection between them, and then the stuff, when it reaches the intersection, switches directions. And maybe that would be something you could animate better. The thing is, if it's not just a single texture, like the thing is, this stuff is all being rendered by STP voxel render, and it doesn't have any flexibility for doing weird texture perturbation things. I added a feature to do texture animation to it actually explicitly for this, and the scrolling was something that was already supported. All right, so everything seems working, so let's check in where we are so far. Partially remove passing logi chunk around. Okay, we still have more. Most of these are just these update functions are only called from this update thing. So yeah, now we're gonna have these two. These two are probably the last of that. Create belt. Oh, there's one more call to create belt. So what was the last thing we changed? Destroy picker. Okay, so we keep going down. Find or. It's like, this is an example of it. I was like, well, it's dumb to have create machine compute the. It's dumb to have the caller create the logi chunk and then create machine call compute the logi chunk and then find or create the logi chunk. But we're just going to embrace that right now. We're just going to say, well, in this case, see, it doesn't have global coordinates. Oh, we're going past the global coordinates though. So that's all fine. So logi chunk. Let's get chunk. X, Y, Z. This is going to be this. It's going to be a lot more code after this refactoring that's supposed to be simplifying things. So now the callers to this, which I think create machine is the only one, but there might be two. Nope, okay, that is the only one. So caller to this now needs to be passing in X, Y, and then or Z has to be so it gets just Z minus 1. And we don't pass in the logi chunk anymore. We still have to allocate it though. This forced allocation here. So now this code goes here. And we don't pass that in. And we pass in the globals. I think that's all right. And now what do we do with or Z? We still use it to set this. We still do this. We still use D here. So we need D. We never use C, I think. We never use the logi chunk. Looks like we never used the logi chunk. So we weren't even using it when we were passing it in, presumably. Create machine. Yeah, it looks like create machine never actually used the logi chunk. So it had to pass a different one in to find or anyway. Create belt machine. Let's start with the same thing. This code is commented out. What was it doing? It was the OR code that we don't care about. Okay. So we Oz. That's all reasonable. All right, so let's find the callers to that and fix them. Oh, we were using logi chunk. Okay, jeez. Just didn't see it. All right, callers. Do the familiar thing. So here's one where I made both of them. I have one that takes the chunk and one that doesn't take the chunk. So let's get rid of this one and see who's calling it. I believe that is just XY belt Z needs to be passed in here. Of course, it's looking directly at this already, so it is super redundant. X, Y, belt Z. Yep. What was that called? No chunk? No, it doesn't have the word chunk in it, right? And then, okay. Program. So we got rid of this one. Nobody's calling it anymore. Find machine. See what kind of circumstance that's called in. Destroy. Get machine ID from a global coordinate. That's basically just find machine. Yeah. Okay. So this is going to be a little redundant. We want that same block of code that we keep using everywhere. Right, I think that's fine. And this can get flattened into this. And I think that's the one that needs the cast, though. It looks like I was using a convention where ox, oi, oz was for offset x, meaning it was relative to the chunk. So I was actually, at least some of the time, being consistent about that, but I don't know if I was always being consistent about that. So I'm saying this is just return find machine now. Let's find all the callers to these. Destroy belt machine. Destroy machine. Run. Go in and destroy a bunch of stuff. We don't actually have any belt machines in the world. There's a belt machine. The balancer. It's supposed to alternate sides on the output. Yep, okay. And I can destroy it. All right. Should leave it. Should put it into the map though. Into the save map. Since I haven't been testing it. Oops. It's what, 8? No, 9. That'll prevent them from getting destroyed. Sneak them by there. And save that map. Okay. So was I said that worked? Yeah, I was just running it. What am I thinking? Let's check it in. Continuing to remove chunk pass arounds. And what was the last thing we changed? Destroy machine. Sorry about machine, get machine ID. Okay, so we're up to here. Get belt ID, logistics, update chunk. This is update block core. That was the function we just changed everything in, so that may be all of it. Get interaction belt. Since we're going to rewrite everything, we can get rid of that. This stuff doesn't do any of that, it looks like. Pass around logic slices. Okay, that's also bad. Except, as I said, in the cases where we're passing around belt run IDs, but we're not passing a belt run ID here. We pass around a chunk ID. And the reason we have the logi slice is because you can recover the coordinates from inside the logi slice. So we could instead make this pass around the logistics, the logi chunk, and the coordinates, and the belt run. Or just the coordinates and the belt run. Or just the coordinates and a belt ID. One of the ideas was that you would be able to get rid of a lot of these get target chunk kind of things because you wouldn't need to know the chunks because you don't need to pass the chunks to anything anymore. You do need to get the target belt. That would become a get target belt function. So for example, we can check if we only have the target chunk until we get the belt out. Does that still compile? Did we use it elsewhere? We did. Oh no, target chunk is a special thing. I forgot. Target chunk is a thing that also returns us offsets and stuff. It's not a logi chunk, it's a target chunk. What is it returning us? It's returning us the relative offset instead of global coordinates. It returns us a relative offset. And it's doing a whole bunch of coordinate fix-ups here to make that make sense. So yeah, so I think we do want to fix this. But I'm at 2 hours and 40 minutes, so I'm going to take a little break. Right. I don't see anything important in chat, so. Oh, I have to redo one of these. Add text. Color. Background color. outside that. Okay, there we go. How do I turn on the background? All right. Let me check my mail real quick. Nope, nothing. Okay, so what was I doing? Oh, I'm in the middle of the Logi chunks, and I was thinking about how these target chunks don't need to return the Logi chunks if I don't need the Logi chunks externally. Like, I want to simplify it to the point where I don't need this code, basically. Did I commit that? Yeah, I did commit. Okay. So maybe need to use those vec3i's more instead of passing around raw coordinates everywhere. So we could say static void get target, and we take an int x, int y, int z that is a belt coordinate. Has to be the start of the belt. See, that's the thing. The belt stores relative coordinates to some base coordinates. So you need the belt base coordinates to get the start of the belt. So if I ask you to pass in the coordinates of the belt, you may not have them without synthesizing them because they're stored in the belt run with the base coordinates. That's why a lot of this kind of stuff shakes out that way. So let's say that we take a vec3i, that's the base, and we take a belt run br, and we return a vec3i, that's the target coordinates. So how do we compute that? We still use this. Take the base x, base y, and base z. We don't need any of that. We need vec3i. Result equals. We're going to return global coordinates, not relative coordinates now. The old one was returning relative coordinates, so we're just going to return this. Why am I retyping it? Then we can use that here. Target. We have to pack up the base though. The belt run. We don't need the outer. This is target.x. Target.y, target.z, oh, plus br and do z. Did we have that? Yeah, we did. Then those Going to the logistics get chunk. Propagate that. All right, we could make a logistics get chunk that takes one of these. And then this is now why does this mask? Because it's the chunk offset. Okay, I believe that changes nothing. I think that should compute the same thing. I don't even know who uses that. Let me check who uses it. Target chunk. That's for belt outputs. Right, that's how one belt feeds to the next belt. Yep, okay, so that's all working. Belts are feeding to the next belts. Okay. Get target chunk. Okay, we're calling it visit. We're calling it an if zeroed function. Calling it turn tick, splitter tick, and belt tick. But we don't use the return values for very much. And you can see here we're synthesizing the coordinates to pass in based on the fact that we didn't get coordinates passed in ourselves, as we were talking about before. So let's actually start here. We'll just kind of do this piecemeal, trying to get this all going. So where am I in this? Where's my to-do? So I did the easy ones of global coordinates and passing around the logistics chunk. Now I'm looking for the sort of subtler ones. This is all leading up to this still, right? And in fact, you can see right now, logistics belt tick is one of the things I want to refactor. So I'm just trying to clean up some of this gunk in here that's getting passed around, just so I'll have less to deal with when I refactor it, when I try to merge them. So if I make logistics belt chunk take that, and we can compute these in various ways. We can compute this by get chunk from XYZ. We could pass in, we don't even need to pass in the belt run. We could locate what belt is this, but currently that's a linear search, so I don't want to do that on ticks. I do that when you're updating. When you place and destroy things, I do linear searches. But I'm trying to avoid the linear searches on ticks. That's why we store the target IDs and the input IDs, so we don't have to do those linear searches. So how do we get a logi slice? I think we don't need to, though. I think that was the point, is we never need to. Logistics get chunk will return us one if we really need it. So now we don't have a SID and we don't have a slice, so these things will fail. Okay, so these all need to do the same thing. Which means I can't start with this one. I need to start with the one earliest in the file, or I won't get useful error messages. So back we go to the earliest one in the file, which is the turn. Okay, so this goes to become int x, y, int z, and the belt run. Logi chunk equals get chunk x, y, z. Now we see what fails to compile because I just deleted those variables. Okay, so here we can't compute the target chunk coordinates properly, but that's okay because we changed to get target, which will just take base, and the point of base being that I don't actually need base for anything except get target chunk. Get target. So wait, get target, instead of taking base, should just take the coordinates of the object. I think that's going to be simpler. So currently to do that, so that becomes this. And now get target chunk doesn't need to compute base, but it needs to pass in the correct value, which is base x plus br x off by plus br y off z plus br z off. Now the callers to this, get target chunk, to look at that again, it's currently passing in base coordinates, but it does have the regular coordinates available if it wanted to use them. It could call get target chunk tc x, y, z, I believe. It's, yep, because that's what I just passed in. BR. So if we make get target chunk take the raw coordinates, so now it takes x, y, z, and then bx equals resembles this. Come on, type correctly, thank you. So that gets us back the values we had. Probably could have just retyped that faster. So at this point, bx, by, z, bz have recomputed what we had before, so nothing's changed, but then this is just in fact recomputing x, y, z. And this is not computing global coordinates yet. We'll want to change that to global coordinates, but we're going to see whether we even need this function at all before we change that. Okay, so that is all correct, I think. So now we go back to look at get target chunk calls. These now need to take global things, but there are multiple of them, so I want to get them all now so I don't miss them later. So this is x, y, z, br. And there should be one or two more? Only one more. I'll take splitter doesn't do that. Splitter never calls it. Oh, because it uses get chunk endure. Yeah. Okay. So now we've fixed get target chunk, but these things are still taking x, y, z, so we still need to clean that up. Did I not update this guy's declaration? I didn't. Okay, so did I change get chunk endure? Why does that? Oh, because it's using the stuff it doesn't have. It doesn't have license it anymore. So I need to change this as well. Get chunk endure. It already takes an XYZ. So this one was already fixed to use global coordinates. So this becomes X, Y, and what about the Z? Yep, just XYZ. So there's one place where things do simplify. Logistics belt check. So here we have to pass in the coordinates, and we don't actually know them offhand. Do long tick, selected belt, sorted ref, slice. Okay, so we have the slice, so we can compute it. Slice x times. It's the same thing right here. Base x plus br x off, base y plus br y off, base z plus br z off. Okay, it compiles. Did I change everything I need to change? Or was I still walking through some stuff? Right, I deleted the slice and SIDS and wanted to see if they compiled, and they did. So I guess there shouldn't be anything else. Nope, okay, didn't get it all. Yeah, no worries about not seeing the fact that's not super obvious. So what could I have changed that would cause that? The visits. What did the visits do? The visits are looping over these things I just built. The last thing I was changing, I guess. Logistics do long tick. I computed these base values and then called logistics belt tick. But that's not the visit. The visit is before that. Here's the visit pass. How does the visit go wrong? I didn't change any of this. Should be S just. This is S also. This is S also. Wow, I didn't propagate this in at all. Oh, that's not S. That's. I just totally misread all that. But I should have that. What are the refs called? Belt ref. There we go. Oh, that's a belt run though. Belt ref. It's just an R. R. That whole change that I made and backed out because I was doing a totally bogus change isn't problematic because the compiler is always going to catch that because the types are all wrong. So it's no big deal to sort of do that thing without paying attention if the types are going to be wrong. If the types aren't going to be wrong, then it could be a problem to do that without paying attention. I like to line this up so I can see the XYZ to make sure that there's no typos in that. So even though this doesn't really match that, you could do it like this though, I guess. Didn't I just do this? I could have sworn I just did that. Oh, because I backed out all the changes. That's why. Compile? Yep. All right. What did I change that would cause this to go wrong? I didn't even look in the debug state here. Target slice is garbage. So tc.s is garbage. it's calling get target chunk. It's somebody calling get target chunk, and I didn't catch that. I thought I went through them, caught them all. Wait, I thought I made get target chunk still compute the same thing it used to. No, I made it take different XYZ coordinates. Okay, so I have to find all get target chunks. I didn't finish doing that. Plus BR X off. Again, in the long run, I want to just get rid of this get target chunk, but maybe I need it for this, for the search. I don't know. Plus BR off. And then, is there another one? What's this down here? Get input chunk. I haven't changed get input chunk, I guess. Nope. Okay, so that's the next one I'll have to do. Doom, doom, doom. All right, it runs. Looks like it's working. What did I change? I changed target stuff. So yeah, that looks all like it's fine. So now let's keep going here. The target chunk, we're still using target chunks, but we've changed the coordinates we're passing to them. So let's do the same for get input chunk. Y and Z. Y, Z. I think that's fine. This one doesn't fill out the coordinates. Just double check that. TC, yep, never use this at TC coordinates. And that's the only place we use it, is in this to do the topological sort. All right, so this now takes the coordinates. So now we have to generate the coordinates. Double check that's the only one. Double check that still works. All right. Now we want to see, can we get rid of this whole target chunk thing? Is it still really being used? So get target chunk. So it's restoring TC, which has a bunch of different things in it. The biggest one that I want to check is, do we use tc.s? Probably not, since it didn't crash immediately. All right. But this one definitely does, right? Yeah, it uses tc.s right here. So visit is taking belt refs, and I'd like this to be fast. This is a topological sort of all of the belts in the factory. So I think this one wants to pass them around and does want this target chunk to return it this data. So what we're going to do is we're going to fork it, get target chunk. We no longer return, oh, we do still return these relative. Okay, so let's not change that. And now get belt run in direction is more like That's a thing we wrote yesterday, and that's more like what we want because it takes global coordinates. So now we make a copy of these. We go find visit, and we put our copy up here. And actually, we want to support target chunk as well. For now, we'll call these vTarget chunks because this is part of the visit system. Call this vget. They just need to be something different so they don't collide with the other one. Vget target. Where do we declare it? vTarget chunk. vTarget chunk. Vget input chunk. All right. Now we can start messing with the get input chunks and get target chunks without breaking that system. So that system, it works in a totally with a totally own private copy of those things. So now we will take our core target chunk and say we no longer need logislice and see what happens. Get chunk endure is relying on it. No, we're just returning it. Returning it. We're returning it. And we're forcing it to 0. All right, so that compiles so nobody's relying on it. Good, good. Now, remember we wrote get chunk to replace logistics get chunk. So now we can look for places that call logistics get chunk and replace them with get chunk. But not if they call alloc. So here's one. Get chunk. Why are they computed relative? What? Who knows? Alloc. This is the reason why I saw that this was in here. So I knew we didn't need them anymore because we were passing in null everywhere. Hopefully. The ones that are passing in null, we can leave calling logistics get chunk for now and come back to that. That one's passing it in. Yeah, because this is part of the V system. Okay. Check it compiles. All right. Now, target chunk. We want to look at what these other values in target chunk are being used for. So we added get target, which will just return the coordinates. So I guess the next question is what SID is being used for. We set it. We set it. We set it, but nobody uses it. Okay. Okay. I just that went hand in hand with the slice, so I was expecting it to go away. Target chunk. So now, target chunk, since it returns offsets and a chunk, if it returned global coordinates, then from the global coordinates, you could compute the chunk. So we can replace get target chunks with get target and then a get chunk. So let's try that. Get target chunk. So this should become but then we store the offset also. The offset that we're storing is not global space. So the first fix to do is to change this offset from being an offset to being global coordinates. Then we can switch it to target. Just double check. I gotta stop doing that falling through the ground there. Looks fine. Everything seems to be working. Okay. Refactoring logic chunk. Yeah, sorry, I wasn't watching. Didn't see the spammer. All right, so right, so I want to make those return global coordinates. Yes, thank you for getting it. I appreciate that. It is a good thing to have moderators. We rarely need them. We very rarely need them, but okay, right. So I want to make get target chunk return global IDs instead of local IDs. So I just want this to return target X. In fact, here, let's rename the variables. And that way the compiler will catch all of the incorrect uses. Okay, so get chunk and dir. Oh, it takes as input globals, but it doesn't return globals. Interesting. Do we want to get all of these, or do we just want to get them one at a time? I think we want to get them one at a time. So type def struct new target chunk. And then this is still going to be the old. That way I can refactor this one function at a time by changing what they take. So this one we will change. We'll start with this one. This one is going to be new target chunk. Okay, so this is just going to be target X, target Y, target Z. And then where we access them, calling a new target chunk. And now these we need to adjust. So this uses the position the coordinates of this TB. So we need to get TB's coordinates to do this correctly. But we don't know TB's coordinates because they're stored relative to no, but get target chunk just returned us the okay, they're all right, so let's be explicit about this. So vector target belt chords. This may turn out to be actually worse. This may actually turn out to be more code in too many places. I mean, we can wrap this stuff into functions eventually once I figure out what it needs to be. But so we need to take our target chunk chords that are now world space, and we need to mask them to get to the. So this is there's a function to mask them. What is the function again? Logic chunk mask. X. I think that's our target chords. That's TCX. and then we add the belt offset. So cut and paste here, buddy. All right. Now we have the world space coordinates of the target belt. Obviously, that can be pushed into a function. I don't need to compute that inline. Get target chunk, right, is not returning us the target belt. It doesn't know about the target belt. It's only returning us the coordinates that are targeted. But this belt, those targets that are coordinated are in the middle of a belt. So we're trying to recover the start point of the belt here. And so it shouldn't be BR, it should be TB. Obviously, because it's the target belt, not the belt run that we're processing. So now, when we go in here, we are currently taking our local space belt run coordinates. So that wants to be X and Y, global space. And we're taking, why is it the, oh, because this is the turn. Right, so it's only one long. We know it's only one long. And then we want to compare its world space coordinates now with the, whatever I just called it, target belt towards .x and EY minus target belt towards .y. And then we have the same thing on this case. And I'm just relying on the compiler to tell me, because I changed the variable name, so any use of it I should catch. Hopefully. And then we have this one. So this becomes new target chunk. Is this the splitter? No. Okay, good. And this is going to have the exact same thing. Right here. So we need to copy the same target belt chords computation, which obviously can get modularized into a function, but when we merge all this code, it will be shared code anyway, so it doesn't need to get used more than once, actually. Here it is. And then what's this right here? Target belt coordinates.x. Well, sadly, I still only have dumb or on the belts. Oops, this doesn't need this other stuff. Because I keep putting off doing that other stuff to do other things. And right now I don't have Photoshop on this machine because I changed machines, so I can't make more dummy art. Target belt chords, I didn't declare it. I only got one of these cases. This is just going to be the same thing. Please say yes. Yes. Right. TB used without being initialized. Yes, I need to do this after I compute TB. Thank you, for compiler, for catching that for me. All right, let's run it and see if it still works. Nope, broke something. Logistics belt tick in here. So obviously we did something wrong somewhere. Slot got computed wrong. Slot is computed from item pods, which is computed from base pods, which was computed from that function we just wrote, which is supposed to be using world space coordinates now. But I didn't update those to use world space coordinates. What did I do in the very first time? I didn't do the full update. I changed this EX, EY computation to use X and Y. That's what I did. So I need to do the same thing in the straight one. X and Y. X and Y. Still have the same problem. X and Y. Am I passing in the global X and Y now? Yeah, I am. But base pos is obviously just going to be totally wrong. 93. EX and EY target belt towards dot X, target belt towards dot Y, and then TC. Is that what target this is? X and Y look legit. Like EX and EY and X and Y are identical. That's actually weird. That shouldn't happen, should it? Oh, that's if you're dumping to the first square of the thing. No, actually, they should be the same. Wait, yeah. Yeah, EX, EY should be the same as this, actually. I'm recomputing something I already have. This is the target chord, because I didn't used to have it. But then target belt chords is wrong. Why is that wrong? Logic chunk mask plus TBX off. How does that come out to 32? How can you get 32 from that? TBX off is 16, but logic chunk mask of TC.x should be like negative 32 or something. What am I missing? What am I missing here? Target belt chords Y. TCX, TCY, TCX, TCY. I don't get it. I don't get it. Yeah, the whole thing about breaking into functions, part of what I'm doing right now is trying to refactor it so I can break it into functions somewhat. But this is a system that wants to run with high performance, so there are cases where you don't really want to break it into functions. You can't always rely on the inliner to do things right. And also, a lot of the times when you have a lot of straight line code, that there's no loop in this entire, I mean, there's little local loops, but the whole thing is not looping. You're just trying to sequentially do a bunch of things, and it's often clear if you keep that code in line as much as possible. But stuff that's common functionality you do want to break out, like this there, if this is a thing I probably will break out into a function if it turns out that I keep doing it. But since the code isn't even right now, and I can't tell why, I want it all in line where I can see what it's doing so I can debug it more straightforwardly, if nothing else. I don't get this. How does that, how do these come out like that? Target belt chords. I don't see anything else writing to it. That should be where it got written to. All right, let's get out of this. I should install source so I can debug that. All right, so we're here. Let's go all the way back up here. Run this again. What's that next statement? Target belt chords. Boom, it computed exactly that. TC.x is negative 16. What is logic chunk? Is that like casting x and logic chunk size x minus 1? I mean, they're signed ints, but they should actually behave. Oh, that's not what I want at all. I want the opposite of that. I don't want that macro. I guess I don't have this macro. That would be why. I want the inverse of that. Let's twiddle parentheses. I want this. All right, that makes way more sense. I want to keep the parenthesis there. And then we gotta cut and paste that to somewhere else. Right here. Okay, that should fix that. There could be something else in here though. We'll see. All right. It all seems fine to me. That was enough of code change. Let's go ahead and commit that. G chunk refactoring. How long have I been streaming? 3.5 hours. Okay. So, what did I end up getting done there? I made target chunk. New target chunk, right. So I want to move other things to be new target chunk now. So we'll make get input chunk, use new target chunk. Get input chunk wasn't actually even returning the other ones. So that probably just compiles. It does. Okay, and then get chunk endure is the other one we need to do. So this now used to do it equals ex EYZ. And then the return value is going to be target chunk. And we go through the same thing here. And this is the splitter that isn't actually operational right now, so I don't really have to do this, but might as well. Since we can just cut and paste things, we might as well get it correct. And then we'll merge them later, and it won't matter that we did this. It's the same pos computation. It's always the same pos computation here. It's not always the same ex, ey computation. Although if I change it to tc.x, tc.y, tc.z, it actually would always be the same. So exey is using y now. Okay. So this one becomes that as well. X, y. And then this one, this is the target chunk. Use that. Y, X. Compute that target belt chunks chords again. Because this is a splitter, it has two of these, so I have to do it twice. I have to declare the variables. Vec3i target belt chords. All right. Yeah, I didn't say you didn't know what I was doing. I was just giving you reasons why I do what I do. All right, so Everything looks fine. I believe target chunk is now dead. I'm only using new target chunk, I hope. So we'll check that. Yep, it compiles, so we're not using that. So now we can put new target chunk back to target chunk. That's how you make a change that you want to be careful about. Rename everything, rename it all back. Find all the other new target chunks. Oh, we can actually just search and replace that target chunk, because there aren't going to be any false things. I'll still do it one at a time, but they're all going to be valid. Yep, okay. Compiles. All right, I'm not even going to run it. Okay, so now target chunk is just computing the target and the logic chunk for it. So we can now change anything that's doing this to not return the chunk and to compute the chunk itself. So let's make a version of get chunk that takes the vec static logi chunk get chunk v vec3i v. Right, very simple. And now get target chunk. We're going to change all of these to not compute the chunk. Now notice this is now doing a trivial amount of work here. And we'll come back and clean that up. This is only getting the chunk already. So maybe we leave this one actually this way and have it return the chunk. But the ones that would return two things, we want them to return the coordinates only. And we could always refactor this to return the coordinates. Is anyone even using it? Or did... Yeah, nobody uses it, that's why. Because we moved the copy of it to the V system. So we actually just get rid of that. So target chunk, we want to get rid of anybody who's using that. So actually we just should take it out. Target chunk. We just take it out of the this. There we go. Now it's just affect the I. We'll switch to that eventually. So now anybody who's trying to use the C, we say get chunk. Oh, we made a function for that. Get chunk v of tc dot tc. Oh, it's not actually vec3i. Okay, great. Target chunk. It's going to contain a vec3i. So it's the coordinates. So called C. TC of coordinates. All right. TC.C. And oh, except TC.C had an old meaning, so we better not call it that. We should call it chord. We'll just spell it out for now because it's going to go away anyway. That was why I was keeping it short, was because it was going to go away anyway, but whatever. All right. So we pass in the chords and we get back a chunk, which we need to stick in a thing. So we need a logi chunk asterisk I want to call it TC, but TC is already used. But it's going to go away, so I'm going to do that because I know it's going away. Let's just hit compile and see what fails. These are trying to use TC, and it's tc2.coord. Get chunk and dir. Now has to do logi chunk asterisk c. C equals get chunk v of tc.coord. This becomes tc2. C. What was the other thing that became TC? I've already forgotten. Oh, that was the chunk. Right, instead of C, I want TC. Because I already have a chunk. I already have a logi chunk named C up here. I don't want to collide with that. So it's a target chunk instead. And that's TC, not C. That's the crucial thing there. All right, and then this needs the same tc2.coord. That's belt splitter, so there's going to be multiple copies of these. We'll just keep redoing it by hand each time instead of trying to cut and paste, because I might break something with a cut and paste bug. So tc equals get chunk v of tc2.coord. It's tc2. Logi chunk srtc. TC is not null. TC. Instead of C, it's TC. This becomes TC. This becomes TC. Logi chunk TC. This becomes TC2. TC2. TC. No. TC equals get chunk v tc2.coord. This is tc2.coord. Is that the last one? That was the last one. All right, try running it. Everything's still flowing, so I don't think I broke anything. All right, check that in. Logi chunk refactoring. I still haven't actually gotten to this simplifying the belt stuff yet. I'm still trying to simplify this logi chunk handling. All right, so now I've gotten those all done. Everything compiles, everything runs. So target chunk is now dead. This target chunk is just a coordinate. So get chunk in dir is really just turning coordinates in dir. So that's vec3i get coord in dir. Doesn't need to take the target chunk. It does take xyz dir. And we're going to eventually rewrite some of this stuff. And get target chunk. Is likewise going to return a vec3i. Not going to return a target chunk anymore. And it's going to return target. I'm going to fill that out. Don't need that. This isn't being done anything. This is just get target now. So get target chunk becomes get target. I hope that's actually all true. We'll see. And get coord in dir was I didn't actually return. Select 3i result. And all of these things are turning into logical programs that I could have written initially, or that I could have just written from scratch. But by doing it step by step, I keep all the code working. That's valuable. Right, that one was using outdoor just so it looked like this one. Okay. So now we have get coord endure and get target. So all these things will break. There's no target chunk anymore. Let's find all the target chunks and delete them all at once instead of later. Okay. So get target chunk now it needs to return. It's not the target belt coords because it's the base coords, so it's target coords. Let's get target chunk. Target. Don't pass that in anymore. And did it become, is get target the one that just became get target? I believe it is. And now we don't have those coords anymore because they're just target. Let's do a global search and replace for that. Comes target dot. I think I can just replace them all. I can't imagine that sequence of symbols appears anywhere else, but all right. Get chunk endure. Undefined. What did get chunk endure become? I've already forgotten. Target. Get coord endure. Right. Okay. So this becomes get coord endure. Select 3i target equals. This takes a target. And that's already been updated. Check return. Let's get target. All right, there we go. That might be the end of what I was trying to refactor there. God, I keep doing that every single time. That might be it, and now it's time to move on to actually combining the belt logics. Looks good. Everything seems working. All right. And you can see this code, it's not necessarily shorter than it used to be because the old code had a little bit less stuff to keep track of, kind of. But the math it's using is now more straightforward. The endpoint of a belt is its start point plus its length times its facing. And then the distance along. This is interaction distance or interaction pause or something like that. There's already a function that computes this. And we can refactor that now. Yeah, the only thing about downloading and compiling it yourself is I'm only maintaining it in VC6. Somebody's done a Linux port, but there's no guarantee it still works. And somebody once ported it to a newer version of VC, but they haven't updated the project file, so I don't think it works. And anyone is welcome to submit a fix for that. All right, so what I need to do is merge this code and try to not break it as I merge it. So the whole reason that it's forked, in fact, is because I started trying to do it inline originally and found that there was too many cases that broke and I needed to fork it or to split it out. But part of that was the interleaving. So now that they're interleaved, I'm putting them adjacent, the turn and the not turn. We'll leave the splitter at the top and not worry about the splitter yet because the splitter isn't being tested, isn't being used, and it's harder. So
what we can start doing is we can literally just start trying to merge this code, or we could try to rewrite it sort of from scratch, but accounting for all the cases. And I think I'm going to try to do the merge because I think that's safer and more instructive. It might be that after I merge, I'm still going to end up rewriting it from scratch, basically. And so it would be faster, again, to rewrite from scratch. But there's some subtleties here with like how these mobile things are being computed, where it's doing it 2 different ways that I don't understand anymore. And I didn't necessarily ever understand it when I made it work, but I did all that stuff because it seemed necessary to make it work. So I'd rather preserve that. So right here, we're going to get rid of turn tick because we're going to try to make turn be inlined. So what we're going to do, I guess we can just do this. Where is that? How do you do that? I never do this. It's up this one? No. There's some way to split. Oh, right. It's that one. So I can split this file and look at it in 2 different places, which I never ever do. And we can go up here to the turn and take a look at what the turn does. So here's what the turn does. So the first thing it does is it computes, it stores in explicit variables where the right start, right left, right end are. And it computes the output direction. So we go to logistics belt tick. We copy these variables in. Outdir that. Then we say if br turn is non-zero, then we use this path. Else we want the straight path. And the straight path, right start is 0. Left start is left offset of br. Right end is left start minus 1. Or the left len and right len are the same. It's not left end. Left len, right len is len, which we're going to compute in a second. So let's move that up. Right len is len, left len is len. Right end, left end are always the same, whether we're in a turn or not. Okay. So now that's computed correctly. This was not in the turn code, and we don't really need it, but we'll leave it up there. That's a way to clear all the belts. And if we're a splitter, we want to do that case first. After that case, okay. Now we get to this, which is the same modes up here. So we have relative facing, whereas this one called the same thing turn instead of relative facing, basically. Okay, so let's use relative facing. That's a clear name. Because we don't want to conflate it with the turn that the belt itself is turning. And we want to use outdir, which we've already computed earlier. So relative facing, this stuff, get target, that's the same. Get chunk v, TC belts, this is all the same. Okay, so that's all good. Let's look at case 0. This looks the same. I think this is handle outputting to turning belt. I think that's done. I think that's what all this code is. Target right, start type 0, right end slot. Okay, so we have the right end slot stuff that we computed here. And this code is explicitly subtracting 1. And I mentioned that. I need to be consistent about being inclusive versus exclusive. Did I put that into do? I don't know. I thought I wrote that down somewhere. I thought I remembered that, but maybe I just said it out loud. So let's use these new things that we just computed, the left end, etc., instead of right end slot, left end slot. Let's try doing them that way. So target right start, target right end -1. I got rid of the variable so it won't compile, so this should be okay. It'll compile if it'll fail to compile if I forget to fix one of these. It might be cleaner to not have the -1, right? And maybe it would be cleaner to have an explicit, to have the end be inclusive. Well, let's see how all of the code shakes out, and then we can always refactor that. This code should be the same because it was just cut and pasted from the original. Case 1 from east to north. This one has a BR_len in there, but in this case, BR_len is always 1, so this computes the same thing. I think these are all going to be the same. I don't think there's any reason for this part to be different. Once we're parameterized on right and left end stuff, I think it's all the same. This attempts to have the correct slate item pos, whereas this has this whole incorrect naming scheme where I used item pos. So this code is the code that's correct. But it's still using this right end slots, so we got to do this. I was trying to use slot name consistently, and I don't have slots in these names, so maybe we come back up to that. So I think all the rest of this to the end of the switch is going to be fine. I think I don't actually even need to compare them, because it's just going to be, yeah, repeats of these. Yeah, the problem with the fact is that you don't see it by default, and you can't even tell it's there by default unless your browser is big enough. Okay, so then we get to the end, and here's where it deviates. But I believe I can use this version. I believe this version will be correct now because everything's got this parameterized. Although it's going to compute left base, and I'm going to use that somewhere else. But I think that's okay. Yeah, that looks fine. Now this stuff is a little different. And again, the curve one is probably right. Goes from right len to 1. And right start is 0, but I'm going ahead and adding it here for consistency. This is an important correction. This is right start. This is left start. Is there anything else like that that I missed in here? Left len and right len, yeah. I should have just cut and pasted it. I should have cut and pasted the top one to the bottom, so that was just correct. All right. All right. Let's try it. I missed one. Missed another one. And the same spot. Local len used without having been initialized. Oh, because I moved all that around. Left base used without having been initialized. Okay, I didn't get rid of that left base. That should be left start. And now that variable should be unused. Good. All right, let's see if that works. Nope. Okay, so something failed. Another uninitialized variable. So the tick didn't quite do something right. tick moved an uninitialized variable somewhere. Target left start, right end. Left end, slot, item pause. Right start, left start. So that's typed to 0. These don't touch items. This looks legit to me. Starts at right end -2, left end -2, counts down. These don't touch items. Okay, so it's got to be one of these cases in here. There aren't that many anymore. Let's make sure this isn't being called. Oh, let's leave the code around in case I want to look at it, though. I guess I should have kept this function around. Check belt run asterisk vr. And then we want to call check everywhere. Nope, we didn't hit that. We hit the add sprite one. How did that happen? Only thing I changed was this tick. Oh, I added the checks to the wrong function. Okay, that would be one reason why. Let's add it to the correct function. Both sides, just to make sure we don't miss it happening somewhere else. Nope, it still is hitting it. How do you, okay. Is my check function correct? Yeah, you can't. Where the hell is, okay. How do, like, if I backed out that code change, I presume it would fail. It would not fail. Therefore, it has to be in the code change that I just did. Did I change anything else I'm forgetting? Oh, this is broken because I reordered the thing, so the diff is going to not show me the right thing. So I can't really look at the diff very well because of the reordering. I guess I can unreorder. Okay, so we took out that call. If it's turn, we could do this computation. Otherwise, we do this computation. And we compute right end or left end the same either way. Outdir is dir plus turn. So dir plus turn is 0 in the old case, so that doesn't change anything. Right end slot to right end -1, left end slot to left end -1, right end slot to right end -1, right end slot to right end -1, left end slot to left end -1, right end slot to right end -1, left end -1, left end -1. But how would the checks not catch it? That was the question. How does my check macro not catch a thing going wrong now? If the only thing I'm changed here are these rights to these items. None of these are assignments, so I didn't bother inspecting those changes. We're not running this code. How would this, right, did I run it before I started these changes? I swear I did. All right, yes, this works fine. And the changes I just made cause it to break. Yep, all right. I don't know. It's a mystery. What? How can this check not catch it? I don't understand. I'd be fine with it being broken. That the changes I made, I missed something. That's fine. I just don't understand how my check macro doesn't catch it. Let's just do nothing. If it's a turn. We could call the old one if it's a turn also. Okay. Now, of course, nothing can get to the turns, so that doesn't really prove anything. It could be broken with the turns as well. But at least it tells us a little bit. It's most likely breaking on a straightaway. I guess I'll just check the diff again. A little slower. So let's right here where we do the add sprites. Oh, that's a curve case. So let's right here. Check B. See if it catches it here. Maybe my check is broken. Apparently my check is broken. Thank you. Dun, 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 dun. All right, now we catch it when it goes wrong. Right here. Boom, one of these is wrong. Which one went wrong? TB, it looks like. Yeah, TB was wrong. Target left start. TB plan. That sounds right. Target right start. That's of course correct. Oh, but it copied from BR. Right, okay, so the error would be copying from right end -1 or left end -1. We want to know what BR len is. Those don't work. Right end and left end do not match here. Unless it's a curve. No, even curves so don't. Why is one of them 16 long and one of them is 8 long? Why do this not match? Oh, because this is items per belt, not items per belt side. I thought it was items per belt side. My bad. All right, let's see where it's being used. It's used there. Where else does len get used? Let's just change it. Yeah, that wants to be the, that wants to be left len. All right. So we actually want to change len to be per belt side. And then this one needs to be ×2, but everyone else just uses len. That's what I thought len was. Let's do this. Clean that up a little bit. All right, any other bugs? Looks like it's all working. Need to test the ramps. The down ramp at least is working. All right. Still got this bug, animation bugs that we got to clean up. All right, the sim is working. All right, so now we can take out our checks. I'm just visiting the code. This code should always be good even for a splitter. All this code down here should be legit for the splitter. And it's only this code that needs to change for the splitter. But we're going to try to refactor this to be even smarter. Make sure it's some compiles. Take out the other checks. That's all. Refactor belt tick. We're a little over 4 hours. I'm going to try to push through and get the belt tick refactoring done here. Maybe get the splitter working. All right, so what we want to do now is we want to split this again and take a look at what these cases are doing and how similar they are to each other. So case 1 and case 3 I know are very symmetric. Case 0 and case 1, which is what we're looking at here. Oh, I didn't really need to split them because case 0 and case 1 are right next to each other, but okay. Like there we go. So what do these do? They compute target left start and target right start. So these are pushing into the middle of the target, and these are pushing into the start of the target. And so they're handled slightly differently, but I'm not sure that they need to be. Pushing into the side is not allowed if the opposite thing is a turn case, so we don't, this part of the code doesn't matter for the pushing into the side case. And then we just check and we overwrite. So that stuff is the same. Check if it's not 0. Check if it is 0 right here. We don't do it. So this one is always writing even if the thing isn't. So this missing if doesn't really matter, I think. No, it does matter. Wait, what is this doing? Why is this always copying? Oh, as long as the target is 0, right? Yeah, sorry. So the target is 0, it's the same. This one just checks that we're not moving 0 onto it and skips that if it is. Okay. Then the belt slot is empty next tick is code that is lacking in case 0. I'm not sure why. Helps control our animation. This would control the animation of going straight onto from a straight segment onto a curve or vice versa. It computes it down here. Uses that. Oh, yes, right, yeah. Probably, though, it should be able to use the same belt slot logic in both cases. It ought to. It would be correct for it to use the same logic in both cases. And then the force mobile if target mobile slots is greater than 0 is this, yeah, okay. So this is testing that target mobile slots is greater than the slot that we're targeting in it, or the position we're targeting in it, and the position is always 0 implicitly. So let's just go ahead and add that. Target left pause equals 0. Target right pause equals 0. And then target, and that's item pause here. Target left, or target. Right, they end up on different sides. That's what's different in these codes. So target right pause. So what we mean by this is it's our right side's target pause. It's that, and then this is our left target pause. Move that up here. And then slot equals left offset TB plus item pause. Left offset of TB is incorrect for curve. So this should have actually not worked for the curves. This shouldn't be left offset of TB. Oh, this if the target is a curve. Yeah, so that shouldn't work correctly for pushing onto curves. So I'm not sure why that does. We can come back and fix that though. It's an irrelevant, it's a secondary thing. So this can have the same code here. If PR items of right and -1 dot type does not equal 0. Just to make them match. So left and -1 dot type does not equal 0. Is that match better. This code doesn't have to be run immediately. It does. Oh, it uses item pause, right? This is now right target pause. This is right target pause. And allow new front must move. Use TB last slot filled next tick, which we should just embed into belt slot. Let's move these down. Left target pause. This one isn't checking belt slot is empty, but that's okay. Force mobile. So force mobile gets used to say that the whole thing is moving. Which is always true if our frontmost one is allowed to move next time. So it should be the same as allow new frontmost to move. Right, which is what I was saying, that these were redundant. They were both forcing left len. I don't know why. I'll probably break it when I take one out, which I'm going to. So let's get rid of force mobile. Since 0 is computing both, and 1 is only computing one of them. So let's keep only the allow new frontmost to move and get rid of force mobile. All right, so now right end, target right start, right end, target right start. Oh, I'm looking at 0 for both of them. Right, okay. Right end, now the target is in slot, so we need to do that in slot. Slot equals target right slot start. I mean, this is slot, and then slot equals target left start. This is slot, and this is slot. Now these are very close to being the same. If they're not exactly the same, let's see. This one has asserts. Okay, so now we need to have a slot left and a slot right. Slot right. This one is slot left. We need to do the same thing down here. That. Now they're very close to being the same. Slot right up to the top. That up to the top. This up to the top. So now we have that versus that. It just adds the assert, but otherwise it's the same. So this block of code is now identical in both cases. So we'll be able to share that. And then this is going to replace this. And so I just need to add checking that to this belt slot macro, which doesn't work anyway. So it's not a super high priority. Okay, let's fix our bugs. It's not item pause, it's left target pause. And here we're using slot, but slot doesn't exist anymore. Oops, it's the other way. Everything's still working. Things go around the corners. Things switch. Looks reasonable to me. There's some kind of pop here. That's not right. These are going too far ahead. So that's the right turn. I changed this computation. +1. Did it used to be +0? Did that look better? When it feeds to this right turn. That's still jumping really far. Is that not the right one? The right side. Wait, the right side should be... These are backwards, aren't they? Oh no, east to north. It's the opposite turn. So it's not even the one I'm looking at. Okay, right. So that's the case 3. What is this one doing? +1. Let's try +0. Dang it, I keep doing that. Yeah, now they jump backwards a little bit. And so that was why I was having them jump forwards, is that I was saying I can get the animation to fix up that. So if having them jump forwards is correct. All right, so now most of this code is the same. We just have to compute these setup things differently. And I need to make case 3 work the same as case 1. So let's cut and paste. Oh, yeah, let's cut and paste it. And then work backwards. All right, here's where the cut and paste starts. So this is going to be replaced by the new code. It's going to be replaced by the new code. This is now left. This is slot left. This is left target pause. This is right target pause. This is all going to be identical. Left target pause. That's not supposed to be 0 plus. Oh, maybe it is. Yeah, because they're both feeding to the right side. That's why. Right target pause. Let's double check that up here. That doesn't seem right. Both of these should be feeding to the left column. So they should both be adding a left offset. So what was the case here? It's a left turn, which I never let it run far enough to see. A left turn, the object on the left side. That's the case I need to check. Okay, so we're computing slot left, slot right, right target pass, right left target pass. Base pause is the same. EX, EY is the same. All right, so I wanted somewhere where a belt turns left onto a belt. Dumps out left onto a belt. So that's this case down here. I don't think I had it right before, but now it looks correct. They both dump onto the left side with an animation glitch. Okay, so now this code can be common to all the ends of all of these. We have to compute right target pause explicitly. Oh, I named them backwards. Right. Target pause. Right. Jeez. Come on. You can type. What is target left start and target right start for? Why do I have both of these? What's the deal with that? That's left target pause. Plus left target pause. How do I compute the slot left and slot right? Elsewhere, left offset. Right, and I don't need left offset. I want, oh no, because it's a target. Yeah. So I don't use, I'm not supposed to use, yeah, so here I do these. So I use 0 and left offset, and I don't handle if the target, supposedly this doesn't handle if the target is a curve, right? Because I don't allow dumping sideways onto curves. I only allow dumping onto curves on this case. So this case needs to handle it, which it does. All right. So now the code is all the same on all of them except for the setup, which means and even EX, the EY stuff, you could compute this in the 0 case, and you should end up computing the same base pause. But the math is different for this stuff anyway, so there's really no reason to merge that. So if relative facing does not equal 2, because that's the case where we don't do any work, then we do the switch statement, we delete case 2, we take the code that's in common, and we move it outside of the switch statement. It won't actually compile yet because the declarations of the variables are all inside. We'll get that in a second. That's the F. Okay, good. That's where that should be. Oh, and the person who was asking what the rules were, here's the written down version of the rules. It's just embedded in the code here. And I'll just move it out of this function while we are playing with this. It may or may not get moved back in. So now all these declarations go outside. This actually gets moved out. This actually gets moved out. Okay, no, it doesn't. Right, because the target can be on different sides. So what we want to do is say int left target side, right target side. And then, so the difference between left target and target left is concrete, but not documented where. Well, here, target left means it's the target thing, the left side on the target, and the target right is the target thing, the right side on that target. Left target is the target of our left, of the current one's left, and the right target is the target of the current one's right. They can both feed to the same opposing target side. So this is concrete, and then left target side, right target side. So left target side is 1, right target side is 0. We want to feed, and these go in the other order because right is the one that's numbered 0. So the right feeds to the right and the left feeds to the left in the straight ahead case. In this case, the right target side equals the left target side equals, which side are they feeding in case 1? They're feeding the left side. I should probably have a right and left macro actually to make this stuff clear. And then the right target pos is that yes, I think that is correct. And now down here we say the slot, it's actually the, yeah, it's not target right, target left. So the slot right is the right target side, question mark, right target left start, or target right start, plus the right target pos. And likewise for the left, it's the left target side, chooses these, and then the left. So here is the thing I was just saying. The sidedness of the target determines the target right or target left choice. I know that's all a little still opaque. I'm not sure how to express it in a way that's clear. Kelimian, however your name is pronounced. They're like that, but not quite. They're not actually fully contractual. They're one-sided contracts. A promise is just a promise from a machine that's promising it's going to take or remove something from the conveyor belt. That's all. Once it's promised, it's promised. I just needed some words, so that was the word I did. Okay, since these calculations are the same, we can hoist them. After all, I was saying we wouldn't hoist them, but let's go ahead and hoist them. And we'll simplify them in a second once we get everything else working. Okay, and then in this case, we hoisted that. Right target side equals left target side equals 1. They're both outputting to that side. Voila. Okay, now I might have a bug here, but you can see that this used to be, let's see where it starts here. Okay, here. This is the old code, although it's actually been tweaked a little bit. This is the old code. Starting from here, switch relative facing. So that's line 1240 down to line, say there, 1337. So it's about 100 lines of code, and I had that 100 lines of code in the turning belt, and I had that 100 lines of code in the street belt, and then I had 2 copies of it in the splitter. So it was 200 lines of code in the splitter. So about 400 lines of code that has now turned into from here to here. And this code, but this code is shared. Right, so to add more cases, where the old thing, adding more cases took 100 lines of code, now adding more cases takes this much code. And so if this all works, or once I get it all working, the splitter is much easier to do because I just have to write where this has 3 cases, the splitter maybe still needs 6 cases, maybe not. I'll have to look at how that works. It's actually going to have to be tweaked a little bit differently because the splitter has 2 different targets. And so I need to still do a little more refactoring to handle that case. But not too bad. It might make the non-splitter case slower, but oh yeah, and I'm sure I didn't get this right. I'm sure there'll be a bug, but we'll see. I mean, I was trying to be pretty methodical, so it's possible I got it right. This thing is a little jumping, so I think one of the directions isn't the right offset still. Although that was that thing I said where that was intentional to try to, because I thought it would be easier to animate to the other position than it would be to animate backwards. But I could be wrong about that. Yeah, this all looks like it's working, so I guess I got that right. All right, so we can delete the turn. Because that's all using that common code now. And we can go back here and start looking at refactorings that we can do here. Let's check it in. And then I still have to clean up the animation. But let's see if there's more I can do here. So one thing was that what I was saying was that this was actually just recalculating target X, I believe, the thing we computed up here. It's saying X plus BR len times face dir of BR dir. And if we look at what get target does, it computes exactly that. X plus BR len times face dir. So we can change this to just be target.x, which we can propagate into here, and that becomes target.x minus that, and target.y minus that. And thus you see part of why I did that refactoring of all this. Now there's no more references to, I mean, it's temporarily accessing this chunk just so it can get this belt. We could actually change that. We could add a get belt with a target ID that you pass in a target ID and the coordinates, and it implicitly gets the chunk and gets the belt for that. And simplify this code down. Move this code into a function like I said. Do I have any thoughts on the Go programming language? Not meaningfully. I haven't ever used it. So what is this doing, right? This is just saying which side, for each of the input sides, which side does it output to, and where does it output to. And that's just different math for each of them. And you can see now much more similarities between how the cases are variants of each other, right? These just are opposite cases of each other. And base pos is a poor name now. I should rename it to something meaningful. Right, so we're just counting how many blocks is it from our target, from where our target landed to where that belt starts. So how far along the belt is it? Which, as I said, is already a function. Although maybe an if-def-out function. And then this is code just, when you're expressing it in this concise way, this code unpacks that. Now I have the target sides, and I can use that here. Belt slot is empty next tick. Right, it was passing in the wrong ones here. So this is right target side, and left target side. And then slots and the right target pauses. Are those still correct? I think they are. Yeah. So we have to clean that stuff up. We have to do the splitter, rewrite the splitter in these terms. But maybe, since we're already at almost 5 hours, I'm going to stop here. Since I got this working. Maybe the final push of this cleanup, I'll have to do another day. Like, I don't know if overall the file got smaller or not. because a lot of things expanded while I was doing that. Once I delete the splitter, though, I will definitely be an overall contraction, I think. But it's definitely way simpler and clearer. There's only one coordinate system being used in here. Like, it is having to do this. Like I said, I'll move that into a function so you don't even see the details of that. But right here, we're just in world space. This is just a world space attraction. And the other approach actually had an advantage, which is like you could potentially extend out further than 32 bits because you were using local coordinates. It would have still worked with more than 32 bits, even though the variables are only 32 bits. But that's not a case I actually care about. I'm totally happy with a world that just ends after 32 bits of blocks. Let's go ahead and make this explicit. So then the other thing is, instead of passing these variables around, I could call a function, right? All three of these could call a function and pass in these 4 parameters. And the function would run this code down here, instead of it being set up some variables that get called down here, right? And then we could just go back to a switch with 4 cases, and 3 of the cases would say, update, endpoint, and these things. Or each one could be 2 calls, one to handle the right side and one to handle the left side. Maybe I should do that refactoring. Maybe that's worth doing. We set some stuff that's used further down in the function. We set allow new frontmost to move. But I don't think we set anything else that's local that lasts. So we just need to pass that in as well. Or it could be a return value. Sure, we can do that as a return value. Let's try doing that refactoring. That's really simple. So this computation gets split. We'll do it as 2 functions to start with, and then see if they can be merged or not. So this is update, belt, and right. And what coordinates does it? What other stuff gets passed into it? It needs target and target belt coords, or we could regenerate some of those. It needs the target belt. It needs the source belt. It's a lot of variables you have to pass in. But let's try it and see how it looks. So we'll start with the belt run and its coordinates. And this stuff that's getting shared can actually live inside this function if it's not needed down here. Like, all this stuff can live inside this function as well. So let's not worry about that yet. Let me move the code down. So this is going to be the right case, and I'm going to have a left case. Again, doing the right and the left separately here, you could do both of them in one function, but then you have to pass in twice as many arguments. Since a lot of the arguments are just going to be the same, that might actually be faster performance-wise. But I want to split them and see how it looks split. That's the main reason. So the left code isn't needed anymore. And I'm just doing this mechanically. Like I said, the 2 are going to be very similar code, maybe identical, but I don't want to compute that yet. I want to go ahead and do it mechanically so that I don't introduce any bugs. So that's all the code that was for the left side. That's all the code that was for the right side. And so now we have to pass in these parameters. Let's do int target left side. Int left target side. Int left target pos. Those are the things that will vary. And we'll do those first. Right target side. Right target pos. So that we can see them immediately. Although it might be cleaner to put everything else on the left, since those things will be fixed sized and these things are variable sized. But we'll see. We'll see how it looks. And now we need these variables. Target left start, target right start. So let's move the computation of those. Target left start, target right start in here. And that means we need the belt run TB. And I know we're going to get, so let's pass in the vector VI target belt coords. That's the coordinates of belt run TB. Actually, let's just pass in vector VI target. So target belt coords can get moved inside to this, which then means it can get moved all the way inside these functions. And we'll end up with 2 copies of them, which is maybe not ideal. But one of the reasons why I'm doing it this way is because this makes it easier when they target different belts for the splitter. So I think this is, like I said, it's going to be less efficient in the common non-splitter case. But we can come back to that. We could performance optimize it if it needs performance optimization at some later date. So we got rid of that variable. All of this stuff actually doesn't need to be computed on this path. And these things are all there. All right, just trying to keep the code kind of compilable in theory. All right, so then this block dist needs target and target belt coords, but we just computed those actually. So we can do this inside. I don't even know who uses it. Oh, the caller uses it. It's used in here. So we kind of need it outside. No, but I was saying, even in this case, block dist is always 0. It should be the case that block dist was always 0 in this case. All right, currently I haven't, oh, I did start moving stuff out. I was going to say I was leaving this so this would still run, but in fact, it's not true. I actually moved it all out. Okay, so we can always still have block dist added on to the target pauses. Left target pause plus equals block dist. Oh, let's see my paste buffer. There we go. Okay, so got block dist out of that code. We still need to get the belt. We're going to rely on that being outside. Okay, so then we get to here and we say update belt end right. That takes the right target side, right target pause, the belt run, X, Y, Z, the target belt, and the target. Now I see that those can be computed internally. The advantage is that I don't compute them twice. So if we were willing to, so that's 1, 0. And that is, what is I said the return value would be? Allow new frontmost to move? Yeah, allow new frontmost to move. Okay, that was 0, 1, 0, 0, yeah, okay. So we actually want you to leave this way so we can see what's going on. We don't need the block dists. Those are being computed inside the thing. So these become this becomes this becomes this becomes this. So this one becomes 1, 1. This one becomes 1, items per belt side -1. And this one becomes 0 comma items per belt side -1, and this one becomes 0 comma 1. Voila. At this point, it's almost, you could just data drive it, right? This could just be tables. All right, so what did I get wrong here? Vec3i target belt coords, target belt coords, target dot x, that has to be arrow x. Let's just do that globally. Target dot is target arrow. Block dist. Slot right didn't clear these. Right end. Okay, so yeah, I have those right end, left ends that are computed out here. I can recompute them from scratch. I only need the right one in the right and the left one in the left, so I can do that. So that should be okay to do. So I use all that computation elsewhere though, so let's leave that alone. Let's just copy out the part we need. So place it back in, copy to the left side. It's a little bit bad in that this assumption is now getting baked into multiple places in the code, but okay, we only care about the right side. And we only care about the left side. And then what do we actually use? We use left end. We never use left start. We never use anything but left end. Okay, so it's just add these together to get left end. And this used right len though. What was right len? So then left end is right len. So this is right len plus this is but that just means they move up and left end is always short side plus long side. Right len, this is len. This one, we actually have to compute that. Right end. What's that? I'm going to change that to right end equals BR turn. 0 question long side colon short side. All right. Long roundabout way. I could have just computed those from scratch, but again, I decided I'd try to just do it as a refactoring so you can see how that works. Len. I'm never computing a len anywhere. Like I said, this is recomputing a lot, but let's do that. It's recomputing a lot, probably slower. I can come back if it matters. Okay, and then this is now the return value. Return 1, else return 0, which is just return. Yeah, and that macro is a Boolean, so I can just do return on that. Okay, this is using something else. Right target pause, right target side. Update belt and right. Void function. Oh, no, it's just because I forgot to make these ints. Or bools. They should really be bools. Block dist. TB. How did that? If TB is down here, oh, because I moved this stuff inside. All right, so we move it back out. Because I was wrong about that. These are all unused. All right, let's see if it works. Looks like everything's fine. It's going to return this correctly. All looks good to me. All right. So rename that variable to be shorter maybe, so this code is clear. And like I said, these are all the same. So maybe reorder these like this. Maybe stick them in a structure so it doesn't Does that look better? Maybe? I don't know. I kind of liked it the old way, maybe. If I data drive it, it doesn't matter. So the main thing is just that I'm not doing these TCTB lookups twice. That's why I'm passing so much data in. Is I could look them back up, but there's enough computation there that I'd like to save that. And as I said, splitting them is so that they can each be actually operating on different targets, which will help the splitter. I don't know. I don't know, which is better. I guess I like that one more. It only works if you have a wide screen, though. A wide editor. Many columns. I don't really need to run that as long as it compiles. Yeah, I think that's reasonable. So now that the code is like this, just doing the splitter from scratch is really easy because the splitter is just a belt that's a little short. Instead of being 4 long, it's like 3 long. And it updates its endpoints to 2 different targets. And so I can easily just put a case in here. If it's a splitter, then it has to compute 2 different targets, but these calls look the same. They're just to 2 different targets. but I don't think I'm going to do it right now. I'll do it next time. Okay, and then I was saying, are these two similar enough that I can merge them? That was the other question. Just move that so it matches. These are named differently, but they function the same. This is all the same. This is all the same. This is the same. This is going to be the difference right here. Left end uses left offset. So this is that thing where I said if you passed in the side number, we can call offset for side. And we need offset for side to know about curves, and it could embed this code in it. Or we can just have an end for side function. Or it could just be inline. And then this is the same. And then this. It's pretty much the same, just different variable names. And then this is the same, except different variable names. So actually, let's do that. Let's do that as their final thing. We'll merge those two functions. No point in leaving, there's so much replicated code there. So, where are we on time? 5:10. Okay, so this should only take like 10 minutes. Update belt end. Enum right 0 left equals 1. We really should be doing that. So which belt end are we updating? Int side. If side is 0, we use this version of the code. Else if side, so sorry, if side is right, we use this version of the code. Else if side is left, we use this version of the code. And we replace all of the, this becomes slot and end. Slot, target side, target left start, target right start, target pause. Target pause. And these target sides can now be left and right as well. It's the same numbering scheme. So slot has to be valid, then end, slot. Oops, I deleted the wrong part of it. Slot, end. Target pause plus equals. Target right start, target left start. Block dist. Block dist up here. Len. What are we using len for? For this computation. Move it inside. This block dist we could expand it in place. It's only used in that thing, but it would get really long. And slot, target pause, target side. Okay, did we fix everything in that or not? No, these all turn to end. Okay, belt end, right. left. Let's search and replace that actually. So it's right parentheses becomes underscore right parentheses becomes parentheses right comma. And underscore left space parentheses becomes parentheses left space comma space comma space. I left out the final space. And then these are right left right. No. What was this one? 1 and 1. Left left. Right. Voila. The right side goes to the right side, the left side goes to the left side. Both of these both go to the left, both of these both go to the right. They go to different positions along there. The one that's going straight on goes to the earliest slot in the thing. And then we can delete the left end, since that's shared now. All right, build, run. Less than 10 minutes. 5 minutes. Assuming I didn't introduce a bug. So this is the joy of refactoring little bits at a time. You do these mechanical updates, your code gets much cleaner, and you very rarely have bugs in your updates. We had a couple. It definitely didn't help that I had one and had to write that check function, and then the check function I had a bug. So I think everything is working as well as it was. So so next time we'll fix the animation here when these things get stuck, that they blow up. Right now they're not animating correctly, so we'll fix that next time, and we'll do the splitter again. And maybe by then I'll have Photoshop set up so I can make some conveyor belt art for the splitter. I don't know how to animate that though. But I think that's good. I'll move this up to the top of the file where we can access it elsewhere. Hey, look at this comment. So dumb. Why didn't I just do that? So dumb. All right. So that's it. So any questions? Done in today's stream. Do you interleave straight belts? Get rid of logi of passed around logi chunks and local rewards. Refactor belt tick to share all code. We'll call it all code because, come on, at this point, that switch statement has two statements per case, so close enough to all. Nobody has proposed any comments, or questions rather, so I don't know if that's because the stream is really delayed. Let's see, what have I typed? I have typed all of the stuff that I just saw. Okay, great. So it's not, for me, it's not very delayed. So I will stick around in chat for just a little bit to answer questions by text. But other than that, that's it. Oh, wait. Have you checked to see how much OBBG pushes your CPU? Was curious since I did a test. Yes. So am I still on the large view now? I think I'm still on the large view. So, I mean, I haven't brought up this, but we can. It's only trying to use 3 worker threads and 1 rendering thread. And because I'm vsyncing, you can see our frame render time. I'm not using the full capacity of the rendering thread. The other 3 threads should be running at basically full capacity. If I look at them here, they're all idle 0. Oh, they just finished. So their idle times just went up to 1,000. But before they finished, if I bring that back up, you can see their idle times are 0. So their 3 threads are running at max capacity. Now, the number of threads you get does depend on how many cores your machine reports. And I kind of have some dummy heuristics. You know, this has 8 hyper threads, but I only want to treat it as 4 cores. I'm going to assume that it won't hyperthread efficiently, so I don't even bother trying to use the other 4 threads. I haven't tested that though. And I don't worry about the fact that the 4th thread isn't getting used to full capacity. Like that's life. We're trying to keep as much. We're trying to only offload work in a straightforward way, and so I want to do as much as possible on the main thread, the rendering thread. So I do want to keep that rendering thread from doing too much work as long as possible, because it's everything is going to be being done on that. I did the test on dual core. It ran fine, but used 1 thread in max best core. So it should have been using 1 worker thread and 1 game thread. And so yeah, how that worker thread is of course going to get totally spammed. And what's the FPS? Well, the FPS it's vsynced, so it's octet 16, 16 milliseconds there. If I turn off the vsync on this particular machine, on this particular world, because this is not a very complicated world, if you had stuff with varying heights in it, you'd have a lot more data. That's why in the STB voxel render I use those cities to test, because they have a whole bunch of stuff going on instead of just being kind of height field like. But so with this totally bogus data, I don't actually have a comment that says vsync. I should have a comment by this. Disable vsync. So let's see what we get with this machine. So while it's building the world at this resolution 2, if frame time is 3-ish milliseconds, I need to filter that to average that over more frames. But it's still building the world, so as it builds the world, it'll get a little slower. So it's probably 3-ish milliseconds, so that's about 300 frames per second. Yeah, just using 1 thread. It's just that thing is only showing the worker threads. That's not showing the main thread running. So you've got 2 threads running. When you see only one of these threads with data, you got 2 threads. So it's done filling out the data. So so there's the thing. It's about to 4 milliseconds, so 250 frames per second. But it's not drawing very many triangles. 13, 14 million triangles is not anywhere near what this engine is capable of pushing. The STB voxel render is capable of pushing. So the problem is how much mesh data that takes. Like it's already up to 500 megabytes in cache. And so if the data was much bigger, you could get twice as much data in twice as much cache. But if you made chunks have about 5 times as much data, it just wouldn't even be able to draw out to this distance, because it would run out of memory first in the 2 gigabyte or the 1 gigabyte threshold. But yeah, that viewing distance is 1800 blocks, is what that's set to. And the fog happens a little bit outside that. And obviously it's super aliasy and terrible looking at that. But if you haven't seen the viewing distance demo, you should look at the STB voxel render demo, which is, I believe, in the FAQ on the left, or you can just search Google for STB voxel render and look at the trailer. And in that, there's some Minecraft scenes that are 1280 block viewing distance, some detailed Minecraft viewing scenes that have that distance, and some non-Minecraft scenes that have or was 1280 maybe 1280 was the non-Minecraft. I don't remember what the Minecraft one was set to. One of them was set to 1280 with a sort of pseudo cityscape. The non-Minecraft one was a pseudo cityscape. I don't remember which one was which, but if you look closely at that, you can see some debug output in it that's showing you the viewing distance. So yeah, in terms of compatibility, like I haven't done any work on that. So if you're trying to run it and it doesn't run well, like, I'm just asking for some an OpenGL compatibility context. And if your thing doesn't have that, like Macs don't have compatibility contexts, that's not gonna work. And so some effort needs to be done to actually make this run on Macs and Linux and on multiple GPUs. And I just haven't done that work. If other people want to do that work, they're welcome to do that work. I will integrate it. The whole thing with the threads, I query how many cores and make a guess what's a good number to run, but I don't know which of those cores are threads and which are hyperthreads, how many are real cores and how many are hyperthreads. So I'm just kind of guessing based on the count. You get back, and in the same way, I'm currently just turning on multi-sampling always. And if you're on a slower thing, that should be toggleable. It should be smart and like kind of estimate how good your stuff is and pick good defaults, although most games don't do a great job of that probably either, but it could at least try. And you definitely want that stuff configurable so that when you're running on a slower GPU, you can tweak it. You want to tweak the view distance, you want to tweak all those things. That's just all work I haven't done. So things that can be done locally, like the Mac and Linux stuff that are just force changes to the code, you guys should feel free to tackle. Stuff that like config screens and stuff like that, that's probably not something you want to do at this point, because like I'm going to have strong opinions about how that stuff should work and behave in the thing. So until I have the first config screen in, and then in that config screen you could add stuff, like until that happens, you probably don't want to mess with that kind of thing. However, if you just want to make configuration variables without GUIs for them, if you just want to look at environment variables even or something, just to have some way of overriding that stuff, that would be totally cool. So if you are interested in tackling that, feel free. Those are things I would definitely not refuse. I may not like the way you do them, and so there may still be work to do to get that integrated, but it's not stuff that on the face of it I would refuse. So, but and right now there is a pound define that you can set to called minimize memory that reduces how much memory is required and pulls in the view distance really, really, really far. And that's not quite what you want. There is already a runtime variable, which is the size of the mesh, and a runtime variable, which is the size of the view distance, that you can tweak. However, the caches are fixed size, so you can't make them larger. Like not the caches, the megabyte cache you can, but the distance that the caches are for the meshes and stuff you can't change. So you want to use the large, you want to compile in the largest size, and that gives you the maximum thing. And then you'd be able to set the view distance down smaller dynamically on an environment variable or whatever. But I just haven't done any of the work on that. Like I just have one machine and I just test on that one machine. I haven't worried about getting it going on other machines. That doesn't seem like a high priority given how far through the project we are at this point. But if you think it's a high priority, or you want to work on it, or you just think it's a high priority, you can definitely do the dummy version of that, the environment variable version of that. Anything else? Will slope blocks be implemented in the terrain builder eventually? The SUV voxel render does support slope blocks. And you can see the slope blocks in the ramps. I don't know whether I'll bother putting them into the terrain generator. You can see them in the SUV voxel render trailer that they're at the very end. I have a sequence where I show ground with sloped blocks, and it even uses very weird sloped blocks. I don't remember if I have that mode enabled in this project. I don't think I do, but so it's certainly possible. I don't know. A lot of my focus on the terrain building is on the new voxel stuff that I'm doing, which I haven't really discussed here, I don't think. And I've just mentioned in Pat's on Twitter, I have a new system that's even smaller meshes, mesh data, but more flexible in what they can generate. And so my thoughts about how to do terrain generation have been mostly thinking about that, and I haven't really been thinking about the OBBG terrain generator at all. So I don't know. It's kind of an open question. I just thought it odd it pegged both cores. Why would it be odd that it pegged both cores, I guess is the question. One was busy generating and one was busy rendering and doing all the other work, and maybe it's a slow enough machine and it was pushing enough data that made the rendering thread not be able to hit 60 hertz. And since it had VSync on, if you're not hitting 60 hertz, you're probably basically going to pick the core. Certainly if it has VSync off, you peg the core. Right, now that I turned VSync off, it should peg the rendering core. So it should peg for, well, it was already above 50% actually, so it's hard to say. But this rendering thing is just now running 100% of the time, right? It's never VSyncing, so that you would expect to peg the core. If you have the VSync on, then it should at least spend a little time VSyncing. But the further you are from 60 hertz, the less time it's going to spend VSyncing, and the less fraction of the time it's going to spend VSyncing. So. That's just updating the to you or the overview. All right. So any more questions, I'll answer in text. But that's it for the stream. Thanks for watching. Bye-bye.